On behalf of ISGF, I welcome you all for the presentation session of Select ISUW 2022 Technical Papers Part 1. I would like to welcome our chairs for this session, Mr. N. Murugesan, former Director General CPRI and Advisor ISGF, Mr. V.L. Sonavane, former member MERC, Mr. Kishore Narang, founder Nanix Technolabs Private Limited. Starting the session, I would like to extend a very warm welcome to the chair of this session, Mr. N. Murugesan. Mr. N. Murugesan is former Director General CPRI and Advisor ISGF, and our chair for this technical papers theme foundational blocks for smart grids. Sir has more than 40 years of experience in the areas of power systems, transmission and distribution system, communication protocol for power system, substation automation, distribution automation, smart grid, advanced metering infrastructure, smart meters, switchgear testing and certification as per national and international standards. I would like to request all the authors who are not speaking right now should mute themselves. I would request my tech team to kindly mute the authors who are not speaking. Thank you very much. Before starting the presentations, I would like to inform that all the authors will be having 15 minutes for the presentation. In the last 5 minutes, we will be playing a timer so that we can stay as per our schedule. We will start with our first theme, foundational blocks for smart grids, chaired by Mr. N. Murugesan. And the first presentation is of paper validation of smart metering technology by Mr. Rajesh Bansal, CEO, BSES Rajdhani Power Limited. Sir has experience in all aspects of power utilities, operations, like network planning and operation, capex optimization, adoption and adaptation of newer technology, usage of OT and IT in maintaining network with minimal failure and faster outage management to ensure reliable power supply, coordination and to meet expectations of various stakeholders, including consumers. I would like to request our chair, Mr. N. Murugesan, to say a few words if he wishes to. Sir, would you like to say a few words before starting the presentation?
Yes. Good morning, good afternoon, good evening, friends. And this particular session is very important because it is a foundation block. It addresses a foundation block for smart grid. And we have excellent speakers and stalwarts in their own area. So it is very important. So we are happy to present this important topic to delegates. Friends, before that, the time is somewhere now almost 20 minutes over. So maybe that each speaker was allotted 15 minutes. We have about 8 papers. So 15 minutes was allotted. As we lost about 20 minutes, so I request
So the broad parameter to be considered for making the validation plans is testing far beyond the applicable standard. Just complying BIS or IS is not effective, is not sufficient. Validation is beyond that. Product testing with respect to the condition experience in the field, not in the lab. Identify the limitation of the system and what happened beyond the limitation. Validation plan should be very important for utility, and utility cannot subdelegate this responsibility to the component company or other company. Of course, apart from the utility, the system integrator has a key role because we are talking about the testing of the integrated system, not the individual component. Validation should be for the system life, and validation should be for cyber security and the data security. And we have to remember, any error in a bill can be a headline in the next day newspaper. This I'm saying as a distribution company. We have seen system malfunctioning, and then what has happened, and that has become a headline. And we have to avoid that. That is the key purpose of validation. Next slide, please. Now, how to plan and do the preparation? First and the most obvious question: who will do the validation? And what should be the validated? Which part should be validated? Or all the parts should be validated? And how should the validation be done? So validation should when we plan validation, we should address the objectives, whether it can meet the short-term objective and the long-term objectives, whether the technology has the adequacy to address the objective, the adequacy of data, correct framing of the logics and alerts, processing, analyzing, and storage of data, and inference and planning actions. So when we do validation, we may get different results. We may see some failure also. So we should have a plan that if from the validation test, what data we'll expected, and if we get data which is not as per the expectation, then how to make an inference out of it and how to make a planning out of that. Next important question is, who should do the validation? I always believe it should be by the utilities, and along with in partnership with the vendors and the independent type lab. So the utility has the biggest stake. And what initial preparations are required to do the validation? First is the manpower training. Second is test setups. And third thing is interpretation of validation results. This is very, very important, interpretation of validation result. In fact, after publishing this paper, the fourth thing I found is compilation of adverse or malfunctioning observed by other utilities. I tell you, this is the biggest learning one can have. Any adversity, any malfunctioning, any improper functioning of the smart metering system as observed by other utility is a big input and is a big validation test, because that has happened in the real condition, and try to simulate that thing on your existing plant system to do the validation. The next question is how to do the validation. Next slide, please. Can you please roll the slide? Yeah, so I have made the validation for 3 different systems. First is how to do the validation about the smart meter. So I have mentioned about the various validation tests, which one can see in the paper. The test of the abnormal conditions on the alerts, events, and measurements that use the unauthorized mean to change the data and see the impact. Failure of susceptibility of any key components or sub-assembly, and then wrong alerts, events, and how they are generated. See, it is very important. If the wrong alerts are also generated, then you stop using those alerts, and that is not a good feature. So first thing is, in the correct condition, it should generate the correct alert. Second thing is, in normal condition, it should not generate any alert. So both are important. And malfunctioning of the latching relay and the communication module. So I have briefed about the technical, how the test should be done and how the inference should be made out of it. So this is just a table which is brief about the test which a utility or a system integrator should do on the smart meter. This is beyond BIS. Again, as I'm repeating, this is beyond the test done by the BIS or by the test labs, or this is by the vendor. Yes, vendor you can certainly involve again the meter vendor to carry out this test, and these are the broad guidelines. Next is the test about the, next slide please. The test for the communication, HES and dash. So here I am talking about the signal fidelity, the time response, and the impact of population. This is very important. The behavior of communication network when there are 5,000 meter, 50,000 meter, 500,000 meter, and 5 million meters are different. The switching off of one meter, does it has an impact on the neighbor meter, and so on. So the effect on the signal fidelity, on the time response with population, with non-functioning of certain types of meter, if the one particular type of the meter goes off, if there is a congestion in between, if there is a noise in between, so what is the impact that need to be seen. Second thing is the impact of the failure of the neighborhood meter, as I was saying, or the DCU on the communication. The next is to response for a command to get a particular data set from a meter and versus the actual data received. Then meter behavior if a command in form of spurious data is sent. If I send a noise data, a spurious data, how the meter reacts. Does it delete the memory? Does it react? Does it overreact? Does it change some data? And so on. Adequacy of command generation security system based on criticalness of command and its impact, and interoperability. So these are the recommended validation tests. Now, these are not the precisely tests. These are, I would say, these are the area where the validation tests need to be done. And then we can simulate the condition. Like if I want to see the signal fidelity and the time response. So I can change with the population, I can change with the numbers, I can change with the switching off some device, I can change by adding the noise, I can change by fluctuating the voltage, I can make some of the device non-function, and then see all this, how they are affecting it. It's not easy if to do a population test for 5 million as a validation test, because by the time 5 million means your entire population is already installed. But certainly you can have this response from the company where it is already installed, and see what is their response, communicate with them, collect the information with them, what difficulties they are facing. If they are facing, you are bound to face, and then have you taken the precautionary measures. Again, technical brief about the test and the making the inference from the test. Next slide, please. So the next is about the MDMS and the smart apps. I strongly believe smart apps are the most important things in smart metering system. My simple logic is smartphones are popular not because the phones are smart. Smartphones are popular because there are smart apps. Imagine if there is no Facebook, no internet, no WhatsApp, no Instagram, or no camera in the smartphone. I am sure the sale will go down to 10%. So people are using smartphone not because the phones are smart, but people are using the smartphone because there are smart apps. So in case we want to leverage maximum benefit from the smart meters, we should have a control over our MDMS and the smart apps. So it is very important to validate the smart apps. We may have a fancy or big list of objectives. We may feel that we can do X, Y, Z, and we can do all wonders on the world using a smartphone. But how strong is your meter data management system? Is it integrated with the rest of the system? Can it handle so much data? Can it handle all types of data? You can have a data which is in GIS format. You can have a data which is barcode. You can have a data which is digital data. And you have so many types of data, whether your MDMS can handle, whether it is connected to the other systems. And finally, your smart app versus the objective. For running the app, do you have the required information? Do you have the required processor speed? Is the various module integrated? And whether the smart app is addressing the objective. Now, these need to be addressed and validated beforehand to avoid any regret. So these are the three levels of validation: at the meter level, at HES and communication level, and at MDMS and the smart apps level. Next slide, please. So in conclusion, planned and proper validation of new technology, including driving the correct inference from the validation test result. Now here I meant is, you may find some failure, you may find some malfunctioning during the validation test, but then you should know how to make inference out of it. It may be that you have gone to a condition which has almost nil probability, or it is the extreme condition. So you have to take a call. If you solve that issue, maybe the cost will go up, maybe you have to invest a lot. So whether you should take a risk, or the probability is low, or whether we should save the cost, at least you should know in advance, okay, my system will malfunction under these worst conditions. And this can help both the service provider and to utility to avoid any future surprises and regrets at a later date. I strongly believe knowledge of validation, knowledge of product is must if you want to avoid any surprises, any regret at a later date. And it is recommended to spend time and resources on validation rather than feeling helpless or frustrated on a later date. So with this, I conclude my paper. Thank you. Thanks to ISGF for giving me an opportunity.
Thank you very much, sir. It was a wonderful thing, and you are a stalwart in meter, spent an entire life in meter. So we are very happy to have you as a speaker and have given wonderful presentation on this complexities involved with this AMI rollout. Friends, our next paper is on methodology of smart planning of distribution transfer with smart meter data. This is also a very important topic which receives lots of attention from utility, and it enhances the utilities viability and so much so on. So I I would request Varun Thakur to present this paper. Before that, Parul, can you give a brief bio about Mr. Thakur?
Sir, would like to inform that Mr. Thakur have not joined yet.
Okay.
So I think we can go ahead with the third presentation.
Okay.
Yes,
That's good. That's good. And the next topic is also very important because the substation is a link, an important link in the whole power system, whether you talk about transmission or distribution or any way. Without substation, nothing functions. So, so though it is a very important thing, and there are lots of things that happened in the last 20 years, and we will be happy to hear from L&T, who were pioneer in establishing various substation level. So over to Loganathan and Suresh. Parul, kindly read their short bio, and I'll request them to.
I will quickly share the presentation for them. The next presentation. The next presentation is on implementation of digital substation for brownfield project by Mr. Loganathan Raman and Mr. R. Suresh from L&T Construction. I would like to give a quick brief introduction about Sir. Mr. Loganathan Raman is Chief Engineer Manager at L&T Construction, Power Transmission and Distribution Digital Solutions, and has 24 years of experience in power system protection, substation automation. Mr. R. Suresh is Chief Engineer Manager at L&T Construction, Power Transmission Distribution Digital Solutions, and has 27 years of experience in power system protection, substation automation. So would like to hand over the stage to Mr. Loganathan and Mr. R. Suresh for the presentation.
Thank you very much for the introduction. So I'm Loganathan here. Am I audible?
Sir, your voice is coming very low. If you can increase your volume a bit.
So am I audible now?
Slightly better, yes.
Yeah. So myself and Suresh both are here together. I'll be sharing my screen. Please let us know whether you are able to see the screen.
Yeah. Go ahead, sir. Go ahead. Yeah, visible.
Yeah, it's visible. Yeah, yes. Thank you to all. So we'll be explaining about the digital substation, what L&T has implemented on a pilot basis in their HQ campus, Chennai HQ campus. So here I'll be moving on this upgradation of these two substations. We have selected two substations within the campus for upgrading with the digital concept of a process bus, where we'll be having digital IEDs are there, which will be communicating with each other by taking the analog data and then exchanging between IEDs. So in this, in this paper, we'll be covering what is the overview of digital substation, what L&T has implemented, what are the unique features we have done in this substation, and also while implementing, what are the challenges we have faced. That also will be sharing as an experience, and also what are the key features of the digital substation. So basic of this pilot project is that L&T want to understand, okay, what is the digital substation, what kind of challenges are there when we convert the conventional substation with a digital concept. So that are the challenges which we want to learn, and also we have to develop the in-house skill so that's suitable for the future market. That is one of the major aim of this project. Then, so we will move to the next slide. Yeah, this is the overview of the architecture which we have implemented in the digital substation. Here, the key point which you would like to highlight here, that 5 different OEMs are integrated together for converting the analog values to digital signal. For example, you can see here. So Siemens relays are there, and Nari relays, GE, Cell, and ABB, all 5 different makes of relays, which we have integrated for the 33 kV base. And you can also see here another substation, Energy Center 2 substation we have. So here we have Energy Center 3 substation. So all the substations, both the substations have a different IEDs from different OEMs. And even if you see, this project involves different kinds of different makes of Ethernet switches we have used for the process bus as well as the station bus. And also we have integrated here ABB RTU and then Siemens RTU in some other substation. This way we try to bring different makes of OEMs to understand what kind of complexities or challenges we'll be facing when we implement in a brownfield substation. That is a key idea of this project. And also to learn about the interoperability system. Here you can see the whatever you have highlighted here in this blue color. You can see that these are the 2 bays where NARI and ABB relays are permanently put under interoperability mode. You can see a merging unit from ABB and then BCPU from NARI. Now both are communicating each other. And here another way, NARI merging unit and then ABB BCPU both are communicating each other. And also to highlight you, all these BCPUs, Siemens, GE, Cell, all we have tested. Both the relays can be communicating each other. With Siemens will be communicating with GE merging unit, Cell merging unit, and ABB merging unit. All we have tested to see, okay, how whether we'll be having any kind of challenges in communicating. All we have tested, and while implementing, we have selected 2 bays to have a permanent interoperability in this case. And to integrate the existing meters, we have the existing data concentrator which is already communicating with the existing EMS system in the L&T FMD system. So we have pulled the data from the existing system and we have integrated to our RTU, Siemens RTU, and from there we have taken to our HMI for our view purpose. So this gives them a feel like, okay, the existing system metering system is also can be integrated with the new system. So we tried all the combinations like replacing the old relays with state-of-art new technology process bus devices, and also convert all the HT base, LT base feeders for remote monitoring and control by using the RTUs, and the meter data is also integrated with our RTU for the remote purpose monitoring purpose. In addition to that, this entire substation is now the data is written on the cloud. You can see here we have integrated the substation with the cloud. So all the data is now getting recorded in the cloud, and this data is used for further analysis. So we'll be able to see the power measurement and the operation using the dashboards which we have created for this particular substation. This is all about the overview of this digital substation. We'll move to the next slide. So just to give a brief, okay, what is the uniqueness of the substation which we have here? You can see here, these are the 5 bays where we have taken different makes of IEDs are integrated. In the first feeder, you can see Siemens merging unit and then Siemens BCPU, which is in the 1 bay. And here you can see Cell merging unit and then Cell BCPU in the 2nd bay. 3rd bay we have a GE, and 4th bay you can see here ABB and NARI both are communicating each other. Fifth Bay and NARI and ABB are communicating each other. This is one of the uniqueness in the substation automation field, where 5 different makes of IEDs are integrated in one single substation. And also another uniqueness, you can see that we have a different makes of RTU, Siemens and ABB, and we have a two different makes of Ethernet switches. One is from RuggedCom, another is from IS5. These are the 2 different makes of Ethernet switches we have used in the system. And as I said, that this substation is also integrated with the cloud. So what are the other key features which we have, which we would like to highlight in the digital substation is on the interoperability. Like now you see all the different makes are integrated in one single system, and also the interoperability we have tested. So we have a confidence that the merging units, different merging units can talk to different makes of BCPUs. This is one key feature which is there here. Even you can out doing the physical connection, since there is a process bus and station bus are there. So we'll be able to simply reconfigure the MUs and BCPUs, so that the without doing the physical shifting of the BCPUs and merging units in the from the feeders to another feeders, we'll be able to communicate each other. And also we have LT feeders. In these LT feeders, we have introduced the features of this load shedding functionality on a frequency-based and power-based system. And the network is also getting managed by seeing whether the port is active or it is dead, or whether the temperature of the ports are okay. What is the usage of the CPU? What kind of packets are getting exchanged from one port to another port? All getting monitored using this network management system. As a part of the cybersecurity, we also implemented certain 3 requirements of the cybersecurity, like to avoid the intrusion. So we have made some RBAC, that is role-based access system. So where the certain users will be having certain access only, and whatever the unused ports are getting disabled, so that nobody will be able to access the system. And also we have utilized this app locker facility of this Windows firewall security. So that is your whitelisting. So that the Excel's, you can see apps are defined, only these apps can work, and any other apps which is trying to install it will not accept it. Similarly, we have the backlisting. We have, that is, antivirus is also implemented. So all these Windows features are also enabled for the cybersecurity functionality, so that our digital substation is secured. And moving on to the next, so while implementing the digital substation, we face a lot of challenges. For example, few make IEDs do not have, because our requirement is that to have a PRP way of connecting the devices with our process bus and station bus. When all other 4 IEDs are able to do, so one of the IED was not able to communicate in a PRP, particularly on the process bus. So this has to be, we have identified while implementing. The another challenge which we have faced is the sample value failure when the merging units and BCUs both are communicating. And there is a key requirement of the time sync. Time sync is also very important for communicating between the merging unit and the BCPUs. If both the devices are not communicating, then the sample value will not be exchanged from the merging unit to your BCPUs. So this kind of an error also which has come in a particular devices when the pulse is not available, time sync pulse, and there is a power failure occurred. When the system get reboot, these 2 devices do not communicate because there is no time sync. So this kind of challenges which you have faced in one of the devices, all other devices are okay with this kind of power failure and all which is happening. So only in one IEDs we have faced this problem. The other thing is that here the GPS signals, whatever we have connected, like the station bus is with the SMTP protocol, and the process bus is synced with your PTP, precision time protocol. So in this case, few IIDs were not suitable for the PTP. That also we have changed by highlighting this to the OEM, and they have upgraded the firmware, and then we have corrected it. So these are the few challenges which we have faced during implementation, where we have taken OEM support and then few challenges we have resolved, still few problems are there. And another case, like when we are trying to integrate with the existing data concentrator, so that was not having the dual master communication. So we have taken the support from the supplier and we replaced the communication card with the dual port. And that way we have overcome the challenge. And also, as usual, when we are doing the retrofit that for HT base, as usual, there will be a challenge here. The major challenge is that the time availability, because during office hour we will not be able to do. After office hour only we have a time to do it, and only on the weekends only we will be able to do. That way we try to plan our activity like, for example, in this retrofit way, we have to completely change the door. You can see that in our previous slides, all these front doors has to be replaced with the new doors, and only your IEDs has to be replaced with the old relays will be replaced with the new relays, but all other equipment has to be retained. So this kind of challenges we have. So how we have managed, like we put this all this boards separately, and then we did all the wirings, bunching and everything. Then we removed the old door with the and replaced the new door within this short period. For example, if you say 7 o'clock evening will start, and then we have to complete it by early morning 6 o'clock. Like this, your 10 to 12 hours time we have to complete one day. So these are the challenges we have faced, and then without affecting the productivity, we were able to implement all the HTBs. These are the few challenges we have faced. We thought better to share with you for on the experience. And you can see one of the quickly explain on the sample value failure, which I was saying that is critical. For example, you can see merging unit, left side and the right side, you can see bay control unit. Generally, the process bus is synced with your PTP time pulse, and there is a power supply is healthy. In this condition, the relays are communicating. The merging unit is communicating with the bay control unit. You consider the case where the power failure is also happened, and then the time sync is also pulse is also not available, then the sample failure error will come. So you can see that in the next, see here now the power failure occurred, and when the power has come back, you can see that failure signals. I'm not sure whether you are able to see that or not. The screen is showing that now it is failure. This kind of an error signals will come up when there is no time sync and the power failure occurred. So this kind of challenges we have faced while implementing the digital substation. These are our key takeaways and also the recommendation while we are going with the digital substation. So one of the key takeaways that using the simulation based, we can use the simulators, and we can inject the sample values in the system for testing all the IEDs. We don't need to physically move to one way to another way from sitting in the control room. You connect your simulator and then inject the sample values to test all the IEDs. And interoperability between the multi-make of MUs and DCPUs are also possible. So that also we have tested. And the failure of time synchronizer could create an issue in the process, but that is what I have explained in my previous slide. So we have to be very clear on the requirement that
Mr. Loganathan, yeah.
Yeah, now I think I'm through.
Yeah, it is.
Yes, sir.
By mistake it has happened. Now, the time synchronization is also important when we are talking about the communication between the merging unit and the DCPU. So we have to ensure that there is a time sync pulse is available. And this can be achieved by using the external GPS also, and also each and every device.
Mr. Loganathan, the slide has not moved.
Am I now it is okay, sir?
Yeah. Next slide. It came and gone. You can show that. Next slide. Yeah, now it is visible. Yes.
Yeah. So this. So what is our key takeaway is that in this case we need a GPS signal. So this GPS signal can be an external GPS clock signal, or relays are coming with a master clock functionality. So that master clock functionality can also be used for syncing the devices. This is one takeaway which we have learned from this project. And also like IEDs are also having the dependency, we could reduce the dependency on one OEMs. So now we have multiple makes of OEMs in this substation. So this gives more confidence to us that we don't need to depend only on one OEM. And there are other key takeaways we have. For example, interoperability. There is a challenge between the optical cities and merging units. In a digital substation where we have a digital cities are there, so we have to depend only on the OEMs. There is no open protocol between the optical city and then merging units. There is a dependency still we have, so we cannot overcome. But merging unit to the BCPUs, that we could have the different makes are available in the market which can be integrated. And also we have challenges in case of bus VTs and then bushing cities, how this digital substation is going to be more feasible in case of bushing cities, because generally the switchgears will be having your cities and then that will be integrated with the merging units. So in case of bushing cities, there should be a separate merging unit for taking only the bushing cities. This kind of challenges we have in case of the bushing cities and bus cities. And there is a limited choices available when we are
Mr. Loganathan, sorry to interrupt, but if you can wrap up the presentation in 1 minute, because
we are at last slide. This is our last.
Okay, sir.
So we have challenges in having control switching devices, tap control devices suitable for the digital substation. This is one of the challenge we have, and also we have complexity in optimizing the core for your main and then busbar protection. So these are the challenges we have in case of digital substation when we want to implement it. So thank you very much for giving this opportunity. Suresh, you want to say something? Okay.
Thank you very much, Lokanathan and Mr. Suresh, having presented a nice things like that. And next is that, from CESC Limited, the implementation of smart pillar.
Sir, Murugesan, sir.
Yeah.
Sir, I think that Mr. Varun Thakur have
Yes, come
joined.
back. Wonderful.
Yes, sir. So I'll just introduce him.
Yes,
Mr. Varun
go ahead.
Thakur and Mr. Akash Kumar. I'll introduce them, and I think we can go ahead with their presentation.
Yeah. And again, once again, a small request is that in the last 40 minutes, we could able to complete only 2 presentation. So I request all other to, go little faster. Within 12 minutes we can complete it. Otherwise, another 6 papers are there. It will go to 5 o'clock. So kindly take in mind. Thank you very much. Over to Varun.
Thank you, sir. So the second presentation is of paper methodology of smart planning of distribution transformers with smart meters data by Mr. Varun Thakur and Mr. Akash Kumar from Tata Power Delhi Distribution Limited. Mr. Varun Thakur is currently serving as HOG Automation and has a wide experience of grid automation and modernization, digital substation, OT cybersecurity implementation, CAPEX planning, grid engineering, vendor development, and other part of various smart grid initiatives and projects. Mr. Akash Kumar is working as an assistant manager, network engineering department, and responsible for 11 kV and below CAPEX planning. So without any further ado, I would like to hand over the stage to Mr. Varun Thakur and Mr. Akash Kumar for the presentation. Over to you, sir.
Good afternoon, everyone. Good afternoon, everyone.
Yeah, good afternoon. Yeah, you are audible.
Yes, sir. Sir, myself Varun Thakur, with me Ankur Sangwan, Akash Kumar and Shubhan Jalani, those who are my colleague. Now we'll further move. The short introduction has been already given. Sir, this is all about the Tata Power. Tata Power distribution has the 1.9 billion consumers, and we have the peak load of 210 megawatt, which was recorded last year in 2nd July 2021. When we talk about our project is aligned with our organizational goal, Lakshya 2023, where we have the 3 parameters of the operational excellence, which through which we are that our project is directly hitting. That is, number 1 is AT&C losses, capex optimization, SADI-SAFI reduction in the nuisance stripping. In this, in our project, we use two technology. We use two technology like smart grid, smart meter, and the active power filter.
Sir, Tata Power DDL has installed around 2.5 lakhs of smart meters in their network, out of which 5,000 has been installed on distribution transformers for the energy audit purpose. And like we already know that each smart meter generates the various parameters like voltage, currents of with 30 meters interval each. And in Tata Power, we have installed the meters on our distribution transformers for the energy audit purpose. But later on, we have realized that these can be used for the inside planning of our distribution transformers, because in the current state, our DT planning was based on our clamp meter readings taken by our O&M staff manually on monthly basis, which sometimes is not accurate, and sometimes due to non monitoring of our loading patterns, it sometimes leads to the increase of a neutral current, which sometimes leads to the nuisance trippings.
Sir, it's lead to nuisance tripping due to increase in the DT neutral current. And subsequent to that, the future challenges we have as the non-linear load like PV penetrations and the electric vehicle charges are coming into our network, which is resulting into more of the harmonics, which deteriorates our DT transformer health. In terms of like the overhooting, failure of the transformer, reduce the transformer lives, nuisance stripping due to increase in the neutral current, which we have talked about. Utilization of transformer is one of another challenge. We are not able to utilize in a proper way due to the presence of this neutral current and the various issues that we have talked about.
Like sir, if we talk about our conventional planning, based on our conventional planning, each year we used to install 100 MVA capacity in our systems. But by using the smart meter data is in our planning of our distribution transformers, in current financial year, we have saved around 24% of capacity addition. That is around 24 MVA of the capacity we have saved in our FY 21-22, either by not installation of transformers or by DT swapping within like overloading and underloaded DT swappings of transformers, and also by installation of the active power filters, we have reduced increased our transformation capacity by 2%, which can be used to release more number of connections. Like sir, if we talk about our planning philosophy, like data from the smart meters is moved to our our dashboard via MDM, and report converts the data into by logic just segregates the data, some of the error data segregates, and we forecast load on each transformers, and then we identify overloaded transformers, and we analyze the load curve of each transformers by using of a smart meters data. And why we are doing this? Because sometimes there is a chances that our peak recorded by our meters may be due to the temporary load shifting, which is not, but actual transformer is not overloaded, and sometimes due to communication error our data is erroneous, and sometimes due to some of the operational issues the transformers was de-augmented, and then we segregate the transformers which are actually overloaded, and we take the corrective actions on these transformers. And this is the snapshot of our dashboard which we are using for the planning of our transformers, which have features of a comparative analysis also.
So these are some of our problem statements, sir. If you see this below picture, we have installed one of our APF at 360 kVA DT at Ambabag. So when we were installing on this DT, we have found that R phase there are currents and neutral. You can see there is a current of 217 current was flowing. So this was a challenge which result into the more harmonic production in the transformer, which reduce the life of the transformer. It reduces the power factor, and it reduce our power factor, which can result into the more losses. So these are some of the problem statement. Now, how this active filter has been installed. If you see in our pictorial view, we having a source, we having a distribution transformer. Here, what is the APF is installed, which is in parallel in line with that. What APF is doing, it is injecting a negative, it is injecting a 180-degree phase shift, zero sequence current into the opposite direction to neutralize the neutral current flowing into the DT of the transformer. Once the DT of the transformer, this will help in reduction of the neutral current of the current in the neutral of the DT. Consequently to that, it improves the harmonics, it improves the power factor, and also reduce the harmonic present in the transformers. So these are some of the this is a brief about our active filter project. Now, when we have done the case study in this, we have tried to identify that what would be the implication of our solar penetration and EV when they come into our picture. So we have estimated that our loss may increase by 13.26% for the non-linear load when it's come into the picture. So we will make a mathematical model by taking all the winding resistance and the LT resistance. Then we will found that if we having a normal load, we will have a loss of 2506. Then this non-linear load will come into picture. The loss will increase to somewhere around 8516. The overall meaning is to say that once we install the APF meter, this 30% increase in the losses will be taken care by APF. So when this PV and electric charges come into our distribution network, it will not impact our network, and this APF will reduce the harmonics. So these are some of the results. When our AFP was on, you can see in brown color our neutral current was 74 and 104. When the APFC got on, the neutral current reduced by 36 and 22. Same is for, if you see the harmonic distortion, it was 6 and 8, and here you can see it will reduce to 3 and 5. Same for the power factor was 0.98, and power factor improves to 1.
Sir, this is one of our case studies related to our temporary load shifting, which we have gone by our conventional planning. We may add up here in some of the capacity for the mitigation, but actually this transformer was not overloaded, as we have seen in our curve. One of the transformer is going high, but other transformer load is very low. This is a case of temporary load shifting. And second case study is our erroneous data. Like in one of the 30-minute slots of data communicated by smart meter, it has a 2500 kVA load, and this is a very error-prone data which we have eliminated by our analysis on our dashboard, and we have also saved capacity addition here.
So, sir, these are some of the key takeaway. We have found in our study that we have reduced the transformer copper losses by 4%, total harmonic distortion reduction by 40%. We have improved our DT utilization factor by 2%, which can result into more number of consumers serving from the same transformer, which will help us in capex utilization for unnecessarily shifting of transformer. As we have already talked about, we have used the smart meter and the dashboard so that we can enhance the safety of the field devices, so we can do the proper planning also. And we can also definitely remove the erroneous data, which was the prior cases when we do not have the dashboard. So these are some of the recommendations that we will going to use this APFC in our only that area where we have the EV charging station coming in and more of our solar penetration. And the smart meter, we will only going for that. That will help us in the optimization of network planning to save capex, as well as the asset utilization factor will be increased. So thank you from our side, sir.
Wonderful, wonderful. I think all your case studies will be a benchmark for the rest of the utility to adopt to see that benefit the whole nation. Thank you very much. Wonderful presentation. Thank you, friends. You have done a wonderful job. The questions will come back later. Friends, the next speaker is from CASC Limited, Calcutta. So this is about a smart pillar box with the digital communication LED distribution systems. This area is also very important, as you can see that many utilities are adopting novel methods to make it very attractive and looks smart like that. So over to Mr. Biswas.
So before that, I would just like to give a brief introduction about Mr. Biswas.
Yeah.
So the next presentation is for the paper Implementation of Smart Pillar Box with the Digital Communication in LT Distribution System, as told by Murugesan sir. And the presentation is by Mr. Nirvik Biswas from CESC Limited. Mr. Biswas has an experience of about 12 years in the field of distribution. Sir has ample experience in the field of operations, majorly in LT network domain. So with that, over to you, Nirvik Biswas sir.
Thank you so much. I'm going to share my presentation.
Yeah, maybe your voice is slightly.
Yeah, is it okay now?
Yeah, is better. Yes.
Yeah. Okay. Yeah, is it visible?
Yes, visible.
Okay. Thank you.
Voice is also good.
Yeah, so good afternoon, everyone. I'm Nirvik Biswas. Today, I will be showcasing our innovative smart pillar box, which is one of its kind, having digital communication for monitoring the fusing, and also with the help of the sensors installed inside it, it would help us to enhance the safety of the pedestrians nearby the pillar box. So this is a brief description about my organization, CESC Limited. We are having a licensed area of 567 square kilometer in Kolkata and Howrah. We are serving approx 3.4 million LT consumers and 1700 HT consumers. So in our LT distribution network, we were having some perennial problems. Firstly, as you can see from the pictures, during any deluge, our distribution pillar box gets submerged underwater in the low-level waterlogged areas. Due to this submergence, there is a high chance of the pillar box getting alive along with the water. The next is that we were following an age-old process of restoration of supply due to DTR, distribution transformer LTHRC fuse failures. Our old process was whenever there are multiple consumer calls from the same area, our technician teams first visits the site, they check the distribution pillar box. If they found out that the fault is at the transformer end, then our junior engineer visits the site and replaces the DTR LTHRC and restores the supply. So this restoration gets delayed due to multiple movements. And the third problem is during any fuse failure in a distribution pillar box, our technician team has to check the pillar boxes from upstream to downstream to ascertain the fusing, and then the supply gets restored. Thus, in this case also, the traveling time and pinpointing time delays the restoration, thus affecting our revenue. So the first graph represents the number of alive calls and the number of unsafe incidents associated with the pillar boxes. So this graph represents the 2017-18 financial year, 18-19 and 19-20. So as we can easily see, the number of alive calls and the unsafe incidents were on the rise during these 3 last financial years. The second graph represents the average restoration time of the fuse failure calls. Here the time taken for restoration includes the travel time and fuse replacement time. We can easily observe that over the period of time, the restoration of the fuse calls is directly proportional to the travel time. As the travel time is increasing, the restoration time is also increasing. So we drill down to the root cause analysis of the problems, and to find the and we have tried to find out the solution with the YY analysis. So in for the DTR LTH HRC fusee, we can see that the final Y is that non-availability of existing reliable technology for remote monitoring. Similarly, for the submergence of pillar box in waterlogged areas is also absence of existing technology to proactively detect the water level or pillar box alive. And for pillar box fusing, it is also same, the non-availability of existing reliable technology for remote monitoring or pinpointing. So what we have done, we had conducted many brainstorming sessions. Through those sessions, we had proposed different solutions to these problems. I will be discussing the final outcome of those solutions in detail. For the safety aspect of the pedestrians nearby the pillar boxes, we had proposed a digital unit, which we termed as the water level indicator. It uses commercially available level sensors with GPRS-based communication. The sensors detects the water level and generates a docket via SMS in our call center screen or our CRM screen. Our technician went to the spot and de-energized the affected pillar box. When the water level recedes, another docket gets generated and the supply again is restored by a technician. This is the dashboard which is triggered from the SMS. Here the red light indicates that the water level has increases, and the green light, it signifies that the water level is under control. Next, for pinpointing and monitoring the pillar box fuse calls, we have installed the CTs and VTs inside pillar boxes. Accordingly, we have prepared a dashboard where the monitoring is done. During any pillar box fuse failure, we pinpoint the particular pillar box where the fuse has blown with the help of our dashboard. Thereby, a docket is generated with the help of a SMS and the supply gets restored by the help of a technician team. So in this way, we can easily pinpoint the fuse failure in the pillar box. Then for monitoring the DTR LTHRC fuse failure, we had installed sensors for measuring the voltage of the incomer cable, which is emanating from the distribution transformer LT terminal. It is having the same GSM based communication module. It sends the missing potential for any one or two phases simultaneously and flags them through SMS. Thus, it mitigates the staggered movement. 2 times movement is now not required as was done previously. Whenever the signal is flagged, it is directly attended by our junior engineers and the transformer LTHRC fuses are replaced, which adds to our revenue and customer satisfaction. The statistical analysis shows us that the tangible gains after implementing the sensor in the 400 number of pillar boxes, which we termed as smart pillar boxes in our CSC system, the unsafe incidents have reduced to 0 in 2020-21 due to installation of these water level indicators. The ART of the pillar box fuse call, it has also been reduced to 1 hour and 15 minutes to 49 minutes. That is an overall gain of 26 minutes. And for DTR LTHRC replacement, the travel time has been reduced drastically from 1 hour 32 minutes to 32 minutes. Thus, we can say that we have retrofitted our pillar boxes with technological infusion to transform our pillar box into new digital smart pillar box. We have given priority to consumer safety and have tried to deal with all the problems related to the pillar box proactively. We have reduced the downtime with the fuse failure indicator, thereby increasing our revenue. Thus, what we have done, we have inculcated a new path of proactive outage management in due course of our project. That's all. Thank you, everybody.
Thank you very much. You have kept your time in time, so it helped us a lot. Thank you, friends. Next is that talk by dynamic notification process for real-time updation of consumer with network using advanced integrated digital platform by Mr. Nishant Singh from Tata Power. Over to Nishant Singh. Before that, kindly read out his short CV.
I will quickly share the presentation for the bio of Mr. Nishant Singh. I request if any author is not speaking, kindly mute yourself.
Yeah, echo is coming up.
Yes, sir. Now it's fine, sir, I think.
Yeah, fine.
I think Nishant Singh logged in from two different systems.
Maybe. Yeah, you are correct. Absolutely.
Mr. Nishant Singh, I would just quickly like to introduce you to our fellow authors. So the next presentation is for dynamic notification process for real-time updation of consumer with network using advanced integrated digital platforms. And the author is, as can be seen, Mr. Nishant Singh from Tata Power Delhi Distribution Limited. Mr. Nishant Singh is working in Tata Power since 2015 and has won Champion Executive Award for his valuable contribution towards the growth of the organization. So over to you, sir. Mr. Nishant, you're on mute. I have sent you a request to unmute yourself.
Okay.
Yeah, now it's...
Can you see the screen? Please confirm so that I can start.
Yeah, it's clear. It's visible.
Thank you, sir. So, a brief introduction about my organization. Tata Power DDL is a joint venture between Government of Delhi and Tata Power. And as you can see here from the table, that right after privatization, there has been a significant improvement in all parameters, whether it's operational or commercial.
Nishant Singh, everybody knows.
Yes, sir. And
kindly.
This is the technology evolution. In the initial phase, we started with substation automation and laying fiber optical cable and mapping of our all asset on GIS platform. And then we implemented SCADA for 66 and 33 kV level. And then we implemented distribution management system and outage management system. But outage management system was restricted to LV level only, where there was a consumer connectivity. So if in case of any interruption at grid level, consumer information was not there. So that problem got solved after the implementation of advanced distribution management system. And recently we have also implemented field force automation and smart meter, and have integrated with ADMS application. So the foundation for a smart grid from our perspective is enhancing the consumer delight. And that happens only when there is a transparency and information flow from DISCOM to consumer and vice versa. And to do that, the dynamic consumer connectivity with our electrical equipment is key, because then only if in case of any interruption at any breaker or equipment, the information will flow accurately and faster. It also helps us in calculating the reliability parameter correctly, whether it's SADI, SAFI, and these reports helps in doing future network planning and maintenance activity accordingly. And the importance of network updation is accuracy in prediction logic, because not 100% of network can be automated. So what we are doing using this platform is using prediction logic. Let's say consumer A is connected with pole A and consumer B is connected with pole B. If these two consumer make complaint, then my system will automatically make prediction to the LTACB, which is feeding to these two, pole A, pole B, connected from that same device. So it is reducing the patrolling time or the fault identification time for my field executive, and is also giving a clear picture to the consumer about the estimated time of restoration. And this clarity gives confidence to my field operator working at site or in the control room. And the consumer loading data and all electrical parameters helps in ensuring that consumer are backfeeded based on the margin available on that particular feeder. And all these helps the utility in better asset monitoring. For the platform, we have divided it into two parts. For HT network, the field user raises request through SAP, and based on that request, GIS department, it creates network updation patch using SIM model, that is common interface model. It contains two files. The first one is XML, which contains the detail of our electrical equipment, extensible markup language, and the other one is GML, that is geographical markup language, which contains the lat long coordinate of that equipment where it is installed. And then this patch gets introduced in ADMS at the end of that outage. For LT network, it is divided into two parts. If it's a temporary change, the control room validates and will update the detail directly in ADMS. But if it's a permanent change, then again the same process where there is an involvement of GIS is there, and the patch gets introduced accordingly. And this LT network application is integrated with my field force application, which pushes the request of any network change through this application for further processing. And at the end of outage, it gets reflected in my ADMS application instantly. And this is the patch window of my ADMS. We have 18 lakh consumer in our geographical boundary where we are serving, and out of them we have installed approximately 2.5 lakh smart meter, and this smart meter is also helping me in this initiative. We are using the ping meter facility to confirm the connectivity and the status of that outage, and we have done a one-time verification through the meter data management system, and have ensured 100% correct connectivity on a real-time basis. And when it comes to the benefit, the major beneficiary of this project is the consumer, as they are getting the service faster. The mean time to restore a particular fault has reduced through that prediction logic, and there is a transparency in service. The consumer can open the TP Detail Mobile Connect app and can see the status. For employee, it is helping the field executive to make faster decision, because the system is making the prediction. The logic is there based on this platform, the consumer connectivity detail, and it is reducing that patrolling time and decision making time to identify the route to reach the site and start the work. This application is helping them. And for organization, asset management and its performance monitoring is being done through this. We have also received copyright for this process, and Tata Power DDL is using it to serve other utilities through BD opportunity. And for safety perspective, it is in boosting the confidence of employees working in control room for automated, and the other employees which is working at site to operate on that network. And so this is the recognition which we have received for this process. Thank you.
Wonderful.
Wonderful.
You kept your time. So, friends, I think someone has kept it. Sorry. So, next speaker is from again CSC Limited. Again, an important topic on transformer monitoring systems. Parul, you can read out a short CV of Mausam Datta.
So the next presentation is for the paper Digitalization of Power Transformer Monitoring System by Mr. Mausam Datta and Mr. Arpan Pramanik from CSE Limited. Mr. Mausam Datta has 2 years of experience in the power sector, majorly in the field of LT power distribution while working for CSE Limited. And Mr. Arpan Pramanik has 2 years of experience in the power sector, majorly in the field of LT power distribution in CSE Limited. So over to you, Mr. Mausam Datta.
Am I audible?
Yes, we can hear you.
Okay. Please wait a second. I share my presentation. Okay. Good afternoon, everyone. This is Mausam Datta. Myself, along with my colleague and co-author, Mr. Arpan Pramanik, will be presenting on the topic Digitalization of Power Transformer Monitoring System. This is of supreme importance in the present days for an utility like CSE Limited, which is involved in generation, distribution, and also transmission of power. To start off with, I first introduce my company CSE Limited to ascertain the importance of this project. CSE is India's first fully integrated electrical utility company, and it has been since 1899 generating and distributing power in Kolkata and Howrah over a licensed area of 567 square kilometer. To talk about the consumer base, CSE serves about 3.4 million LT consumers and about 1700 HT consumers. To provide uninterrupted and reliable quality power to our esteemed consumers, 300 power transformers in 18 substations and 122 distribution stations at voltage levels starting from 220 kV and down to 6 kV have been operating continuously in the system. Thus, proper monitoring of these power transformers is highly recommended to ensure their reliable operation and the pristine health. Transformers are the centerpiece of electricity and networks, and hence they immediately require integration of digital and smart grid technologies. Transformers, enabled with digital capabilities, allow remote monitoring and data analytics of its vital parameters in real time. This ensures efficient and cost-effective power handling and also enhances the reliability and enables greater utilization of grid assets and power networks. In this paper, we are also introducing IIoT, that is Industrial Internet of Things in the system, which allows digitalization of asset management that helps to organize the data for optimum utilization of valuable assets like power transformers. To assess the relevance of this remote monitoring of power transformers, we can point out several advantages of the system. First of all, remote monitoring is comprehensive. That is, every asset can be monitored and supported remotely. Additionally, it can provide automatic updates and alarms. Remote monitoring collects system statistics over the time. When viewing this data in monthly or quarterly reports, long-term trends can be identified even before they reach levels that would trigger an alert. This system is more efficient than manned system. It operates automatically without any failure due to lack of consciousness. Problems can be monitored from anywhere, and remote monitoring system may be an economic and reliable method for proactive maintenance of the transformers, which in the long run will reduce the chance of sudden breakdown or failure. During realization of this system in practice, the first step is to identify the parameters, both electrical and physical, that affects the condition and health of an operating transformer. This table shows the selected parameters. Some of them can already be accessed remotely. For example, the electrical parameters can be accessed using the SCADA system. For example, the voltage, load in amperes, etc. And we have also identified various parameters that can also be incorporated along with these existing parameters. The various sensors that may be required to monitor those parameters have also been identified here, which have been installed in strategic locations of the transformers. For example, vibration level can be monitored using vibration sensors, oil level in conservator using potentiometer or VGA camera fixed with the emoji dial, tank temperature using temperature sensors, humidity inside breather using humidity sensor, etc. After selection of various parameters that are to be monitored remotely, the second step is to convert those obtained raw data into meaningful information by assigning proper codification logics. Based on range of values, data have been grouped in several classes and different color codes have been defined for different ranges of data for ease of understanding and better representation. Finally, a maximum point is needed to be set above which notification or alarm is to be generated. For example, for topple temperature transformers, we may set 70 degrees centigrade as the maximum safe value and a notification is to be produced whenever it exceeds 70 degrees centigrade. The next step is to transmit and store the huge amount of data for real-time analysis and archival purposes. The data measured using different sensors are sent to a gateway unit known as AirSprint 1030N. It acts like an RTU or remote terminal unit
Good afternoon, Navneet.
Which gathers data from the equipment and transfer them to the cloud. The data sent to the MQTT brokers gets saved in the web SCADA, which is a cloud storable system which is highly scalable storage space. Data from the CSC SCADA system are sent to the web SCADA directly. From this cloud storage space, web SCADA, we can download the data anytime for analysis purposes. In the future, the data from the web SCADA can be accessed via an API to be featured in an user-friendly app. Now we focus on several case studies, that is the actual parameter variation that we have obtained using the data after successful installation of the sensors. This graph represents the variation of top and bottom tank temperature and percentage of oil level of conservator varying with the loading and ambient temperature over the time. The next graph describes the variation of breather air humidity and pressure. In this graph, we can see that the humidity inside the breather remains lower than the ambient humidity over the time, which ensures that the breather is operating efficiently. This initiative has opened new avenues in the domain of proactive and preventive maintenance of power transformers. The goal in the near future is to eventually install this remote monitoring system in all of the power transformers in the system, which will enable long-term trend analysis of all of these transformers. With all the data in hand, standard reference values may be set for each parameter at different times of the year, which may be used for comparison. Analysis of physical condition of the power transformers alongside loading data will eventually lead us to even distribution of load among various transformers that will reduce the stress on a single transformer. With the reference values set, whenever abnormal value arises for any parameter corresponding to any anomaly in the operation of that power transformer, these data may be archived for further analysis and to find the cause of discrepancies of the transformer. Finally, the end game is to deduce the trend of the parameters which lead to the failures and abnormalities in the equipment using machine learning so that asset life and performance can be extended through predictive maintenance and maintenance cost can be curtailed in the long run. And with this, I would like to wind up with my presentation. Thank you all of you.
Very nice, Anna. You have kept your time and it's very interesting presentation, especially on power transformer monitoring and maintaining the assets. So, friends, the next speaker is from Indian Demonstration Unit in Delhi. Over to Franchise Gassels. Before that, Parul kindly read out a small CV.
Thank you so much, sir. So the next presentation is for the paper Electric's project, installation and commissioning of the Indian demonstration in Delhi by Mr. Francois Cazes from Schneider Electric. Mr. Francois is a senior engineer in mechanical and automation domains of École Centrale Nantes and is an application architect in Schneider Electric. So without any further ado, over to you, sir.
Do you hear me?
Yes.
Yes, sir.
So I will share my screen. This one. Okay. Do you see my screen?
Yeah. Two slides. No? Two screen slide is visible. Yes.
Okay. So, okay. 1 minute. I will disconnect one probably. Let me. Okay. Okay. Do you see the two screen or?
Still two screens are visible.
Okay. 1 minute. I think I will do differently. 1 minute. Sorry for the delay.
Does not matter. Otherwise, also you can go ahead.
Okay. I will do differently. Okay. Okay. And I think we need.
Does not matter. The audience will be able to see what you are going to put. And now it is visible. Only one. Yeah.
So I will speak about the Electric project, what we are doing on that. And first of all, I will present you what is the Electric's project. So Electric project, it's a project budgetized by European Union, Horizon 2020 European program. And this European program is to study the implementation of battery energy storage system inside the public microgrid and to serve some what we call energy community microgrid including DSO and utilities. By doing this study and integration of battery energy storage system, we want to solve some customer pain points, like, for example, the minimization of energy bill by maximizing self-consumption of renewable energy, maximizing the ROE of investment by minimizing the network reinforcement, for example, ensuring continuity of the power supply for all the customers, decreasing the grid congestion on voltage or on power by involving, for example, prosumer engagement and make them aware about the energy consumption. So on the right side of this slide, you can see all the consortium involved in this European project with 5 demonstrators deployed. 4 demonstrators are deployed in Central Europe, and you can see, and thanks to some relationship between India country and European Union, 1 demonstrator take place in India, in Delhi city. And this is the one I will talk about. So, sorry, here. Okay. So the Indian demonstrator, it is a public microgrid, public network with 3 LV public feeders, 3 LV lines providing energy to customers. On this public network, there is quite 35 prosumers and customers, and among them we have a school of 4,000 students. It is based at Saint Xavier School, north of Delhi, and the substation where we are implementing the equipment for this microgrid is based on inside the Saint Xavier School area. The answer provide and the microgrid provide to solve some pain points as I explained. And so the substation, we have provided many equipment, 1 transformer of a power of 630 kVA, On the public line, there is some PV field connected with a maximal power of 200 kilowatt peak. And also on this microgrid, we have provided a battery energy storage system of 200 kVA of power and a storage of 270 kilowatt per hour. The objective of this project and of this microgrid is to provide with the equipment an energy community management system to manage this microgrid. It is based on the hardware equipment installed on the substation and some analytic application installed on the cloud to provide forecasting and to manage the microgrid. By doing this, we will provide some key elements to solve the pain points. So energy storage system to increase integration of renewable sources, PV field, and so decrease the bill and increase the self-consumption of the microgrid. Power quality improvement thanks to some smart meter provided by Tata Power, which will be the end user of the microgrid. So with some smart meter implemented on the customer premises, we can monitor the energy consumption, build some models, and doing this, we can optimize the behavior of the microgrid. So the prosumer involvement is done thanks to this DER program based on the smart meter and by some analytic. Let me say. Using the telecom communication, we can involve the customer and let me say. Performing the demand response program. And the resiliency and the continuity of the service of this microgrid is ensured thanks to the grid forming capability of the battery energy storage system to ensure continuity of service even if the grid is falling down. If I am go in the detail of the substation architecture, so on the bottom you can see the 3 feeders providing the power to all the customers connected to the substation, and we have 2 incomers to manage the grid source and also the battery energy storage system source. All these incomer and feeders are connected on the same busbar systems, and all these equipment are embedded in what we call an energy control system, ECC, which help to connect all the electrical equipment. Between the grid and the ECC, we have put a smart transformer with a tap changer, which help to manage the voltage and to change the voltage and to ensure the right voltage on the customer premises. On the cloud, we have what we call an energy management system. So all the substation is providing information to the cloud. With our energy management system, we can do some forecast and manage the self-consumption. Even we can do some frequency support. Another application managed by a partner, ODT, is to compute let me say, the grid behavior and to provide some service for voltage support and avoid some congestion on the public grid by asking to the customer to change, for example, or to disconnect some loads on the grid. And to let the end user, Tata Power, to manage the system, we are also providing a SCADA system. It can be locally or on the Tata Power premises to help the Tata Power to manage all the substation by some SCADA system available either on site or remotely. So regarding the installation, as it is an European project, one rule is that all the equipment are made in Europe. So one task is to perform last year. It was to provide to ship all the equipment from France to India. And it was done last year. And so for this, we face what we call the container shortage crisis due to the sanitary situation. And also we ship the battery system. And so for that, we have to manage refrigerated maritime container to ensure the safety of the battery cells. Regarding the site installation, so the substation is inside the school, and you can see on the right some picture of the substation. The battery container was laid beside the substation, and also regarding the installation, one optical fiber was laid between the PV field and the substation to ensure the monitoring of the PV field through the substation equipment. Regarding the electrical installation and to ensure all the interoperability of the substation, we lay the power cables between the transformer, the RMU, and the battery system and the LVECC. About the control wiring, all the sequence of operation is managed through some control wiring and through some digital wiring. So some control wiring has been laid between the RMU, the ring main unit, and the transformer to take account, let me say, the monitoring of the transformer, the working condition of the transformer, about, let me say, the pressure of the oil, the temperature of the oil, or the humidity of the oil, and also according to the status, we can disconnect the transformer in case of any issue. Some control wiring between the RMU and the LV Energy Control Center, for example, for the intertrip function, and also many control wiring between the LVECC and the battery energy storage system, share of the main breaker status and the main voltage to ensure interoperability. All the control systems stand on auxiliary power supply and UPS because this system is able to work even in case of grid loss, what we call off-grid condition. And to ensure this, we need an UPS to supply all the control system of the substation. And all the algorithm, as you can see, is managed by what we call an RTU, a T300 equipment device to ensure all the sequence of operation of the substation. And you can see there a state chart of the sequence of operation to manage all the operating mode and the transition between grid connected mode and off-grid mode of the full substation. This sequence of operation is ensured thanks to some control wiring and so also thanks to some IT network. And on the right, you can see the complexity of all the IT architecture embedded in the substation. Many digital devices embedded on the LVECC to ensure the communication and to ensure the communication between external relay, the breaker, and the transformer with the RTU T300 on the right side of the picture. The SCADA server also, it's embedded in the energy control center, gathering all the monitoring data and providing some command to the switches, the BESS system, and the EMA controller, which ensure the connection between the equipment and the cloud. For the communication with the cloud, we have several access. Some is for remote access to ensure troubleshooting, in case of issue on the substation. And so let me say continuous and daily algorithm apply on the substation, one by ODT to ensure demand response program, and the other one by Schneider Electric, what we call EMS function to ensure the service and the use cases embedded in this application. And the last one is to ensure communication with the Tata Power premises to have remote access through the SCADA HMI provided by the SCADA server. This IT network is based on several physical layers with several protocol, Ethernet, RS-485, and also optical links. Several protocols like Modbus serial line, Modbus TCP/IP, IEC104, and HTTPS protocol. And one subject of this application also is to ensure the cybersecurity of the whole installation according to the new rules apply on this kind of application. And it requires us to, let me say, configure a firewall and modem and Ethernet switch to ensure interoperability for the remote access while ensuring also the cybersecurity access of the installation. Takeaway and recommendation. According to this project, so we have developed what we call a public prosumer MVLV installation for energy transition. What we call at Schneider Electric electricity 4.0. Let me say it's a convergence of electricity and automation technology to ensure this kind of application. Also, we learn about what we call international and cross-cultural collaboration between Europe and India with, let me say, several meetings, weekly meetings apply to ensure synchronization between the team. And also, what is important in this kind of project is to have local expertise support to ensure the commissioning and the installation, and to have technical support on site to help us in this kind of project. Thanks for your attention, and feel free to ask.
Yeah. Thank you very much, Frankage. Next, over to last presentation by our friends, elderly friends and stalwart in power systems, Mr. M.L. Sachdeva and our friend Narendra Singh Soda on flexibility in power systems. I request you to keep it as minimum time as possible to keep up the time. Thank you, friends.
So the final presentation for this theme is of paper flexibility in power system by Mr. M.L. Sachdeva, former Chief Engineer, CEA, and Mr. Narendra Singh Soda, former Executive Director, Power Grid Corporation of India Limited. Mr. M.L. Sachdeva is industry-leading expert in power transmission system technology involving development of power transmission system. Mr. Soda has rich experience of over 44 years in Indian power sector, having contributed immensely in project implementation, operation, maintenance, renovation, and modernization of EHV transmission lines and substations. So over to Mr. Sachdeva and Mr. Soda. Sachdeva sir, we can't hear you.
Who is presenting, Parul?
Sir, Mr. M.L. Sachdeva is here.
Okay.
Is that?
Yes, sir. Yes, sir. Carl, you have his presentation.
Sir, I can see that Mr. Sachdeva is speaking, but somehow we can't hear him. I request if Sachdeva sir can log out and rejoin again.
But it is not visible to us. I do not know whether others are able to see. I do not know.
Yes, we do not able to see any presentations.
Okay. Welcome, sir. Good afternoon, Kishorji.
Good afternoon, sir. How are you?
Good, sir. Good, sir. Good, sir. Nice to see you.
Sachdeva sir, we can see you, but we can't hear anything, sir.
Hello. Can
yeah,
you do the
now
presentation?
Yeah, I
Hello.
can do that, sir. You can do that, sir. You can do that. We are all waiting
Please
for
do
you.
it. Please do it.
So we
No,
are
presentation.
up.
Slides are
Yes,
with
sir. We
you.
are uploading your presentation, sir.
Okay. So, you're going to which other?
Yeah.
Are you hearing me?
Yeah, I can hear you, sir. Now the presentation is also visible.
Okay. Now,
Yeah.
I'm Srideva, which is going to speak on the flexibility in power system. Please proceed next. Next slide.
Yes.
As you are aware that power system has changed from centralization to decentralization, and all the rotating machinery are getting out from the system, and the renewable generation is coming up. Next is map shows the energy system of India with the solar and wind and other things. And then India has made a ambitious commitment in COP26, which was held in October, November 21, that it will set up 500 gigawatt renewable energy services and reduce carbon emission by 1 billion megaton by 2030. Net zero carbon energy by 2070. With these commitments keeping in mind, we have to ensure that how we set up our system. Next, please. Next. Now, flexibility is mostly attributed in the past by the synchronous rotating machines, and once they are the kinetic and inertia, whereas now the renewable systems, mostly inverter based, and then helped by the wind, VES, and HVDC. They are supporting the system. Since the kinetic energy is decreasing, the inertia is also decreasing, and the control system need frequency control system is support. Flexibility planning is done in 3 steps. Step 1, step 2, step 3. Step 1 is which flexibility is assess current flexibility of the system, and then production cost monitoring and network racing. Second is if there is any gap between the model done and the racing, and then redo it again. And then third one is the assess future flexibility involving. Next, please. Now, to check up the system requirement are renewable with making an impact on the system, CA carried out a study, optimal generation capacity mix 2930, and they worked out from the National Electricity Plan, which was made in 18, worked out the status with 21, 22, and then using the Ordina generation operating software, assess the 2930 condition, and which they found that the maximum absorption around 85.32% on 3rd July 29, and considering the coal protocol platform 55%, 50%, 45%, 40%, the RE curtailment was observed to be 14.68% to 12.9%, 11.84%, and 10.56%. The IEA, Niti Aayog, and TERI and NRA, they carried out studies of making a regional model for the power system, and Gujarat state power system model and then observed that out of 10 rich renewable states, 4 states have already crossed near the minimum level average of 8.2%, and they have gone into Karnataka 29%, Rajasthan 20%, TN 18%, and Gujarat 14%. The TERI and NERA study, which was done, it was a wind comparison only, and then they found that Tamil Nadu is already in 2018 is 8.4 gigawatt wind, and Karnataka was 5.2 gigawatt. The recommendation of both these studies were that we shall use some platform which is a open platform and go on carrying out the studies of timely as the renewable gets increased into the system. Then everybody knows the Pan India light off, which was carried on 5th April 2020 for 9 p.m. For 9 minutes. Here they have observed distribution lights residential lights were asked to be put off at a specific time, and then it was observed that the estimated residential load which was to be off was smaller than the actual one. The recommendation made was that they shall go for the proper estimation, and even one suggestion was to put a spare control center due to the condition which has experienced in COVID-19, and improve the flexibility of the distribution system. Control center, as far as spare is concerned, nowadays the virtual stations are being created, and as such, it can be controlled from remote, from any place. And my feeling is that we shall not go for a physical spare load control center. Next, please. Next, please. No, ancillary services in India. CERC is responsible for ancillary services in India, has started first NLDC was authorized to do in 2010. Then it was followed by 2013, 2015, 2018, and 2021. Final draft was has been circulated for comments. The final draft includes 3 cases: primary, reserve, ancillary services, then secondary, reserve, ancillary services, plus up and down, and then tertiary reserve services, up and down. Now, primary services, as seen, it was given by the governor action. Secondary and tertiary was the limited limited power control was done by and different load centers, and then they were made to responsible for that. CERC also now aim to bring battery storage and pump hydro storage into the ambit of frequency control and ancillary services. Ancillary services used in India. Next, please. Next. Go next. The present ancillary services which are used is inertia, which is first few seconds, then slow tertiary 15 to 60 minutes, then generation, rescheduling, marketing more than 60 minutes, and unit commitment hours to day, and partly primary now is done few seconds per minute. This is the present operating system. AESC and Mitsubishi in Delhi, they have installed 10 megawatt and for 1 hour to augment, to connect it directly to grid, and then facilitate the stability of the system. CA in 500 gigawatt up to 2030. They have recommended 27 gigawatt, 4 hours capacity storage, and now the action is being taken to schedule implementation. Tata Power has similarly got order from for 100 megawatt. Next, please. Now this is the for the frequency containment reserves in other countries, ancillary studies in other countries, which is normally based only the containment and the fast frequency resources. Now survey shows that what are the countries, and they are doing this, and studies also being carried by Texas, then South Korea, South Africa, then Ireland, and other this thing, and they have tried to observe that which system is good and which system needs modification, and this and more details are available in technical brochure of Shigure 851. And interested people can look into that. Next, please. Next. This table shows the frequency containment reserve and frequency, fast frequency response of various components which are being used in the system. So it can be seen through, it gives you the time scale under the FCR and FFR. Now, the synchronous generators, similarly, other equipment like batteries, like load, like smart loads, synchronous condenser, solar PV, and other. These can be seen and made compare with the what is being done in India. Next, please. Key takeaway is that whatever studies we are doing, that shows, and as the renewables are changing till the whatever has been set up to 2030, and later on, these studies shall be regularly done to see how the system needs storage, what system storage and battery and this inverter, which is nowadays instead of it is now for guiding inverter, IBR. Then CA determined optical festival 2930, but it has to be really see year by year wise and see that whether how much it is in coming to or any changes are taking place. The recommendation of IE and Niti Dev shall also be considered while doing the studies, and they shall use open platform or model so that it can be adjusted. CERC has already already put the this frequency ancillary services in the market. Then other countries like South Africa, Ireland, Australia, USA, these people have carried this study, and the major requirement is they are making frequency containment reserve or FFR. The GEB, but GB grid code as modified in February 22 and included the wave and renewables and other this thing into as a part of the generation, as a part of the maintenance of the stable operation of the renewable system with the renewable. Thank you very much.
Thank you very much, sir. Thank you for a wonderful presentation. Friends, we have no issue, sir. So, friends, we have completed all our presentation, and we already stepped into the other sessions timing by 20 minutes. So, friends, one or two questions, audience can raise it either through raising the hand or placing in the chat box. So, with one or two questions, we'll wind up this session. And one question we already answered, why the current is neutral current is has increased the systems.
Does any of our participants have any questions?
They can either raise their hand or type it in the chat box. If there is no other questions, I will ask one question to Tata Power. This is on methodology of smart planning of distribution transformer to smart meter data. So they have used that APF things to neutralize this, the harmonic currents and other things. So before going to that, can the author, Mr. Varun Thakur and team can explain that how did they go about it, first of all? And how do they size these APF systems like that? And what is the cost about it? And how we can able to recover it, or what are things like that? Any studies done on that? Tata Power, Mr. Varun Thakur.
Yes, sir. Sir, can you repeat the question? Actually, due to disturbance, we are unable to.
Yeah. We are also going to the other sessions time. Very short question. You had a wonderful presentation of the methodology of smart planning of distribution transmission smart meter data. In that one, we also seen that APF is put into service to neutralize the harmonic currents, and by that way the capacity and all such things have been done. But before going to this active filters like that, so have you done the studies? How did you go about it? How did you size this APF, that the filter design, active filter design, how did you go about it? It is maybe useful for the other utilities because the problem is common.
Yes, sir. We have studied the transformer in our network, and we have identified the three transformers in our distribution network, which were having the maximum neutral current. And after that, we have identified one of the transformer which was having the highest neutral current of 217 amperes. In this way, we have segmented and targeted our transformer in such a way which having a maximum number of neutral current in that, and plus the future aspects of PV solars and battery charging station coming up in that particular area.
Now my question is that now how did you design, that active filter capacity, and what is the price about it, and whether with this one you could able to get it or any other,
yes,
studies done?
Yes, sir. The capacity of active filter is directly proportional to the amount of current flowing through the neutral. Suppose if this is a 150 amperes of current is flowing, for example, say the example of 100 amperes of current is flowing, then the APFC should be of somewhere around 100 to 120 kVA of rating. In this way, we have selected it. And if you talk about the price part of it, it is somewhere around 2 to 3 lakh rupees, and depends upon the amount of current we would like to neutralize.
Wonderful, wonderful, wonderful. You have done excellent work on this. Thank you, friends.
Mr. Margushan?
Yes. Good morning, sir. Good morning. I think you are in US.
I have raised one question to Loganathan, that in case that where is data patches? Is it in cloud or in their own location? There's no reply from him. And what is the software or what is the platform being used?
Hello.
I think you would have sent it directly. So I have not seen that. Yes, audible, sir.
Yeah. So the data is getting processed at the cloud. So here we have a mechanism to push the data on the cloud, and the application will be on the cloud. And there will be a dashboard, which with the dashboard we'll be able to see what is the power flow measurement and everything. That is how we have planned to do this.
The cloud has the facility for analysis.
Yeah, it is Azure cloud.
Sorry, I'm not hearing properly.
It is Microsoft Azure cloud.
Okay. Thank you.
Thank you so much, sir. Thank you so much, Murugesan sir, and to all the authors for the theme. We would quickly move to our next theme, which is smart grids for smart cities. And the chair for this session is Mr. Kishore Narang, founder, Nanix Technolabs Private Limited. Mr. Kishore Narang is, as I told, founder of Nanix Technolabs Private Limited and our chair for this for the technical papers theme. Sir has over 43 years of professional experience in education, research, design, and technology advisory. Over 30 years of hardcore research and design development experience in field of industrial power, IT, telecom, medical, defense, aerospace, energy, and environment, and over 10 years of consulting and advisory experience to different segments of business and industry. So with that, I would like to hand over the stage to Mr. Narang, if sir would like to say a few words before we start the presentation.
Sure. I think we are already running late, but I'll just take a few minutes. How many speakers do we have? 3 in this session?
Yes, sir. For this theme, we have 3 authors with us.
Okay. So I think the topic is very concurrent because smart grids for smart cities. As we always say, so I don't know whether people know, I'm already leading the smart city standardization as in BIS as the founding chair of Smart Infrastructure Sectional Committee, as well as Vice Chair Strategy and IEC System Committee Smart City. So in smart city parlance, we always say that smart grid or the electricity infrastructure is the backbone of the smart city. Without the a good electricity, robust, resilient, sustainable electricity infrastructure, cities could not become smart, or for that matter, their basics, you can say, functionality or their sustenance itself will be questioned. I think it's a very relevant topic. And now, how does a smart grid support this smart city, and what kind of an interplay we have? I will first let the speakers talk about their perspective. Then, if they have not covered any aspect, maybe I'll share my thoughts at the closing. But let's get started with the first speaker. Will that be all right, ma'am? Ashwini Arora, Mr. Ashwini Arora.
Yes, sir. I'll just give a quick, brief introduction about the author, and then we can start with the presentation. So the first presentation for this theme is of the paper "Accelerating Wind Power Deployment in India Through Decentralized Plants" by Mr. Ashwini Arora from Council on Energy, Environment and Water (CEEW). With more than 4 years of experience, Mr. Arora is working as a program associate in the renewable energy team with CEW and works on policy, market, and regulatory frameworks at the intersection of power and renewables. So, without any further ado, over to Mr. Ashwini Arora.
Yeah, thanks, Parul, for the introduction. So I'll just quickly share my screen. And am I audible?
Yes, we can hear you, sir. But it will be great if you can be a bit louder.
Yeah, sure. Yeah, sure, I will be. Yeah. Okay. So is my screen visible to you all?
Yes, sir.
Okay. So good evening to one and all, and thanks, Parul, for the introduction. So I have been joined by my team members Disha and Payal. So I would suggest that if you guys have any question throughout the course of the presentation, feel free to post it into the chat box, and we'll try to address this as and when the time permits, and or even during the course of the presentation. So moving ahead with the presentations, with decentralization at the heart of the energy transition, I present before you our research on the decentralized wind power plants as a means to accelerate wind deployment in the country. So let us first look at the history of how basically wind sector has evolved in the country, where it stands today, and what is expected of it into the future. So at present, if we look at the total installed capacity, wind capacity contributes only 10% in that megawatt mix. And when it comes to the generation mix, wind generation is only 5% of the entire demand of the country. So looking at the history starting FY08, we found that India had approximately 8,000 megawatt of installed capacity. And during the course of next 10 years, 10 to 11 years till FY17, we got to an installed capacity of 32,000 megawatt, which was a very high growth rate where wind sector actually outperformed every RE sector actually. However, in this particular year, the reverse bidding regime was introduced rather than the feed-in tariff, which was going on previously, and that policy change hit the sector hard, and it was a very slow growth which this sector actually witnessed. And over the course of next 6 years till today, at where we almost stand at the end of FY22, India installed only 8,000 megawatt additional, bringing down the year-on-year growth rate from 17% to just 4% over the last 6 years. Now, if I look at this 40,000 megawatt number, which is there as of today in India, and look at the state-wise distribution, how this capacity is diversified across the different states, primarily the wind-rich states, we find that Tamil Nadu and Gujarat are the core states, or where most of the concentration, where most of the interest of the developers and investors is lying, and more than 45%, rather up to 50% of the installed capacity of this 40 gigawatt is lying in these two states only. So that would definitely kind of intuitively let you question that, can we install more capacity in these two states? Is there space available? Should we look at the other states, which I have shown in the graph itself towards the right? So let us look at the target which India has posed for FY30. That target is 140,000 megawatt. which basically says that India has to install more than 12,000 megawatt each year, starting now till FY30 to be able to achieve its target. So, but with the interest being so much focused in Tamil Nadu and Gujarat, let us see what kind of challenges the sector might face and which will definitely hamper the growth of the wind energy sector in total. Okay, so let's look at the challenges with this high concentration in just these two states of high wind speeds. First problem that definitely comes is the problem of land availability and land acquisition, because land is always limited with a particular state. Next challenge which comes is for the transmission sector to keep up pace with the new capacity being installed. So just wonder, we are installing 12,000 megawatt every year and transmission has to keep up pace with that. That's a huge challenge. Third challenge comes around is the right of way. So if we look at these three challenges, we can say that if we go ahead more with deploying too much of capacity in these states, then there are bound to be project deployment delays by the developers, and which will lead to cost overruns and definitely make the project loss making. So one of the solutions can be, why not look at the other states which I showed in the graph in the previous slide, like Maharashtra, Karnataka or other, where wind speed is relatively lower but still okay. So but again, though the state itself poses a challenge. First challenge would be, since the wind speeds are lower in those states, the generation or the capacity utilization factor which will come from this high scale, large size wind power plants, that will be lower. Second challenge would be, these wind power projects which are of like 500 megawatt or 1000 megawatt, they have very high development risk. So if I couple this high development risk with lower generation, you can just think that it will further add to the woes of the developers who will be willing to set up their plants over there. Now, the third problem that will come in these states is the mechanism of reverse bidding that we are following, which let the market favor the lower tariff. So already so many risks are there. Further, that power has to be provided at a lower tariff. Obviously, that will make the project unviable for the developers. So then what is the solution? If we really have to kind of meet up our target, how we can further accelerate? So one of the potential solutions that we present to you today is the small scale decentralized wind power plants, which focuses on these low to medium wind rich states or low to medium wind rich pockets, and then see whether these plants are actually being able to provide some cost benefits and some socioeconomic benefits as well. So that is what I will be presenting you into the upcoming slides. Now, in this slide, I present before you that what is the proposed deployment model. And this model is designed, that decentralized small scale wind power projects model is designed to deliver on certain key objectives. So if you look at the first image on the left, it talks about that it will boost the entry of small and medium scale investors and developers into the region. Presently, we just have kind of the large players, but with these small scale power plants, these developers and investors can also get into the sector. They can set up the power plants within the range of 5 megawatt to 50 megawatt, and these 50 megawatt plants can then get aggregated and provide power at a particular say pooling substation or somewhere, where now these power plants, these 50 megawatt power plants which we are limiting up to size, they are set up in a land which is near the STU network, the state transmission utility network. The reason for that is, I already told you that there are challenges related to the transmission infrastructure. So we identify locations where the transmission network is already available and they are going underutilized. So these plants can further utilize without adding to the added fixed cost into the sector. Next is how this plant will be connected, at which voltage level these plants should be connected. So there are existing CERC regulations which talks about that these plants can actually be, the plants with this much small size up to 50 megawatt can be connected at 11 kV, 22 kV, 33 kV or even beyond. And the off-takers like DISCOM and other obligated entities who have to meet their demand at regular intervals can actually get into some contractual mechanisms like PPA with these decentralized power plant developers and meet their demand. So in this entire deployment model, some of the benefits which generally come is, first, as I told you, small developers and investors can actually kick in. Next, it utilizes the underutilized transmission capacity which is already lying with the state. So no transmission augmentation is required. Third, it leads to the creation of jobs locally. So that is also one of the thing that is important when this energy transition is actually taking place. So all this in decentralized fashion, it leads to green recovery in this post-pandemic area and leads to an equitable energy transition for the country. So going forward, we actually try to quantify these benefits and see how analytically we can prove whether this model is feasible or not. So for that purpose, we divided the land into different categories, which is zone 1 to zone 5, based on primarily two parameters. One is their mean wind power density. Other is the average mean wind speed that is observed in certain land pockets. So you can see there are zone 1 to zone 5, and when we calculated the average capacity utilization factor, and further the levelized cost of electricity, which is LCOE over here, we find that since because of the low wind speeds in zone 1, zone 2 and zone 3, capacity utilization factor is lower, which leads to higher levelized cost of electricity. Now when we talk about zone 4 and zone 5, these are the existing areas where a lot of crowding and a lot of investment is already happening. So that is outside the concern of our study at present, and we focus on top 3 zones which have higher tariff. And this itself is one of the problem, that the zones we are focusing on gives higher tariff, and some mechanisms have to come so that these tariffs can be, the risk associated with the higher tariffs can actually be mitigated. So for that purpose, we actually did a case study for a Maharashtra Discom, where we tried to estimate the savings the Discom will get by installing a 50 megawatt plant in a decentralized fashion, obviously, in zone 3, which has a CUF of 30%, which I showed into my previous slide. And for that purpose, we calculated the landed cost. So for the entire lifetime of the project, that is 25 years, we find that without any indexation in the landed cost, the cost is flat at 5.13 rupees per unit of electricity. However, to mitigate the impact of the higher LCOE, one of the proposed way would be to go ahead with the indexation, where this tariff of 5.13 is redistributed across the lifetime of the project. So it starts with a lower landed cost and it goes towards a higher landed cost, so that Discom can realize higher savings in the initial 10 years of the project and lower savings into the remaining lifetime of the project. So like nowhere I'm saying that there will be losses. So obviously I'm talking about profit in the beginning till the profit in the end. So these are two ways by which landed cost can be determined. And how did we determine this landed cost? Actually, this was on the basis of the approved average power purchase cost for the Discom, which we received from the MSc DCL document or the Maharashtra Discom documents, where we excluded the RE out of the total APPC given, so that we can see how much of the what can be the avoided cost, which can be used to determine the savings for the Discom, which I'll show you into the next slide, how this landed cost has actually been used. So when we talk about calculating the savings for Discom with these landed costs that we get for zone 3 with this 50 megawatt wind power plant, we actually looked into the avoided cost for the Discom and what Discom will have to pay to the developers of these power plant. And the difference between the two is basically the savings, right? So there were three costs which is kind of getting avoided by the Discom. One is the fixed cost, the other one is the variable cost, and third is the non-solar RPO penalty cost, which is notified by MERC in case the Maharashtra Discom defaults upon its RPO. So again, we looked at the entire lifetime of the project, and we considered two cases. One, where the plant is connected at the STU level, the state transmission utility level, and it has to wheel across the state transmission network to the Discom substation. That was one. Second was we considered that plant is connected directly nearby Discom substation, so it does not have to be wheeled from the throughout the basically state transmission network that is present. So obviously we are kind of overcoming the losses once we are connecting it to the Discom substation level. So let us look at the benefits which the Discom or the savings that a Discom is likely to get accrued. So in the first case, where we have not considered the impact of indexation, that was a flat line of landed tariff which I showed at 5.13, the green color line over there. So we find that the savings are relatively lower in the beginning, but non-linearly it increases towards the end of the lifetime of the project. However, if we redistribute that landed tariff, that the tariff is lower in the beginning and higher in the later part of the years, we find that Discom is likely to get more savings in the initial part of the project, that is likely 8 to 10 years, and lower savings will be accrued towards the post 10 years of the project. Also, with indexation, you see that the savings are relatively more uniformly distributed rather than in case of the non-index part, which is the green color. So these are the two things. Next, we considered that if we are connecting it to the DISCOM substation level, since the transmission losses would have been overcome, obviously the savings which DISCOM get by getting the connection at such DISCOM substation level are relatively higher. So the trend remains the same as it was without indexation. The only thing is savings get on a bit higher side. Similarly, if we go with the indexation in tariff with the plant connected at the DISCOM substation, again, the trend remains the same. Savings are almost uniformly distributed with higher savings in the initial years, lower savings in the next later years, but it is relatively higher than a plant which is connected at the STU level where the power has to actually wield through the transmission network. So the net benefits, these 25 years which you see the year-on-year benefits, if we kind of look at the net benefits which the DISCOM will receive, with indexation or without indexation, with this 50 megawatt plant in zone 3 of Maharashtra.
Mr. Ashwini, I'm sorry to interject in between, but can you please wrap up in 1 or 2 minutes because the time is slightly, we are behind the time.
Okay. So if we look at the total savings, we find that the DISCOM is likely to get a benefit of around 280 crores to approximately around 335 crores for the entire lifetime of the project. So other than those savings that I just mentioned, there are certain costs which the state will have to bear. One of them is the grid balancing cost to integrate renewable into the grid. And then there are benefits related to the lease renters, the benefit to state in terms of the land conversion charges to set up these plants, and also the local job creation that will actually take place due to the small scale wind power plants. All these numbers are for a 50 megawatt plant. So if overall aggregated capacity is quite higher, these numbers will automatically get multiplied. Now, I mentioned to you in the beginning that we have a 140 gigawatt target, and we have to accelerate the wind capacity fast if we really want to meet that target. Thus, these decentralized wind power plants are also site specific, location specific, though they are getting aggregated, and it is boosting the entry of small scale developers. So there have to be certain enablers for the implementation so that the risks associated with this kind of model can actually be mitigated. So one of the way is to have proper procurement guidelines for the small scale wind power plant. Then there has to be wind resource map for the entire states which have to be mapped, and such information has to be made available to the developers and investors so that they can actually take an informed decision and even identify the technology they have to deploy these small scale wind power plants. Next is they have to identify the spare transmission capacity for which the load flow studies will be required. Then these small pockets of land which will be spread across the state, they have to be identified, when a complete database of such land has to be made so that the developers and investors can actually go there and actually look at the information and decide whether or not they want to bid for these kind of projects. Next is the permits and clearances, which is itself a very tedious process for setting up any infrastructure project. So for this, since it is a small scale plant, there has to be something called single stage permits and clearances that will be required, which will reduce the burden on developers and investors. Next will be the assurity of the payment that these small developers and investors should get from the off-takers, primarily DISCOMs in this case. And last but not the least is, as I mentioned, the high tariff which is there. Some mechanism has to come up to mitigate that impact, and indexation, what I showed in my slides, the graphs, that was one of the mechanism, but it does not, there can be more than that. And we are currently looking into such mechanisms. We are trying to identify and develop such mechanism based on some key principles. One is such a mechanism should actually attract a lot of bidders so that there is sufficient competition in the sector. The price discovery which comes for these 50 megawatt power plants should be sustainable so that they can be different rounds of bidding. Next, there should not be underbidding that results because of the design of mechanism, and there should not be any project delays. So that mechanism has to look after everything, along with creating local jobs, along with promoting domestic manufacturing, and even looking into the aspects of some innovation in technology that might come up. That brings me to my last point, that what we are doing currently as a part of analysis. One is, as I mentioned, identifying and developing such mechanisms for a small scale plant, and then trying to develop this concept of decentralized wind power plants in form of a central program or a scheme with a proper practical facilitation framework for the off-takers. So this is what we are focusing at present. So with that, I end my presentation, and in case you guys have any queries, you can feel free to reach out to us either in the chat box, or we have the email IDs mentioned on the screen. You can mail us and we will be more than happy to get back to you. Thank you.
Thank you, Mr. Ashwini. Any quick questions, though we are running late, but I think we have some questions. Can you go through the question and answer now, or how would you like it? Any questions to be answered live, or you'll be answering them in the chat?
Mr. Naran, this is Disha, co-author with Ashwini. So I've tried to answer the questions on the chat box.
Fair enough. Fair enough. Thanks a lot, Ms. Disha, for this efficient mechanism. Thank you. So let's move to the next speaker. And the next speaker is Ms. Surekha Deshmukh, and from IEEE Pune section, and she'll be presenting her paper on data analytics enabled inertia, volatility assessment of smart grid and enhancing grid resilience, say in presence of DER. Yeah, Ms. Surekha, over to you, and rather to Ms. Parul to first introduce you.
Thank you so much, sir. Ms. Surekha Deshmukh is from IEEE Pune section and has over 22 years of experience at education and industry sector. Ma'am's current professional role is Utilities Domain Consultant Analytics and Insights, TCS Pune. So with that, I would like to hand over the stage to ma'am.
Thank you very much, Parul. Thank you very much for that kind introduction. And thank you, Mr. Narang, for sharing this particular session. I hope I am audible.
Yes, very much. Please, loud and clear. And
let me just minimize my screen and let me get to the presentation mode. Now, in view of the time slot which is given for each and every speaker, which is around 15 minutes, let me try to give justice to 15 minutes. Sure. Now here, as I belong to data and analytics space, and I've been observing power sector for more than, say, 2 decades, I wanted to discuss on the green energy enablement and green energy embarkment journey across globe. And that's one of the reasons where, based on our observations, whatever we came forward, we have themed it in terms of the topic having title Data Analytics, where it enables understanding and assessing inertia volatility, which is an inherent property of DER, looking at very large penetration of DER. For example, if we take example of Australian grid, then over there you will find more than 40% of availability of power is there from renewable. And when we have discussed this particular penetration of DER into grid with the experts from AEMO and some of the utilities from Australia, we came across that one thing is which is really very good, that we are embarked on this journey of net zero carbon. That's very good part of it. However, this renewable energy sector has come up with certain challenges as per operational challenges are concerned. One is intermittency. So definitely power system operator, generation utility, they need to be ready for compensating for this intermittency, having some sort of a firm support, supply support, generation support in terms of either storage capacity or in terms of fast acting generators. So first, handling uncertainty because of renewable is very, very important aspect, which is an operational challenge for utility. That's one. Second is, as per inertia is concerned, we all are aware of role of inertia as per resiliency, stability, and robustness of power sector is concerned. So with more and more penetration of renewable, which is quite a decentralized presence of renewable sources, act as a part of network, as a part of grid, the immediate observation is on inertia. And that's why we thought that, okay, fine, let's talk about inertia, where the third aspect, which is also very important for all utilities and stakeholders in this green energy domain, they are about price of power. Many market operators have seen negative price of power because of surplus generation available in the grid, and they do not want to ramp down their generation as per thermal generation or say other generation plans are concerned. So some of the parts of the globe have observed price of power going into negative zone. So that's also very impactful operational challenge that operators or say electricity utility stakeholders they are observing. So out of these couple of challenges which have come up with an opportunity, we thought that let's focus on this challenge of aspect of changed inertia of the system, reduced inertia of the system, and then having deployed smart meters, having deployed or having data coming from PMU, SCADA, IoT, sensors, we thought that why not to create more and more visibility of the network, because that's the prime objective of deploying all these smart meters and smart metering infrastructure and having this digitalized transformation of electricity utility. So the immediate helping hand that we get is that now data is available. And using that data, what we can do, we can try to understand inertia profile of entire network. Once we understand inertia profile of network, which will be node dependent, which will be time dependent, in other words, the way we forecast load in future, in very coming future, we really need to forecast inertia offered by the system so ever as to take so many preventive measures of retaining resiliency of the system. So keeping in mind the requirement of the transforming grid, which is a very smarter grid, we thought that let's take up this particular thing. Now coming with the power sector domain, we all are aware of frequency, which is pulse of power sector, and this frequency gets observed in terms of its overshoot, nadir, and even frequency nadir is that particular dip which is very, very important to evaluate if we really do not want our switchgear to mal-operate. So for every grade, having deployed certain percentage of conventional generation, certain percentage of renewable sector, and knowing the load profile of that particular network, one has to evaluate the frequency dynamics of that particular network, because now load is a random variable, renewable generation is another random variable. Obviously, it has got an impact on frequency, which is going to become more volatile in nature. And then in that case, understanding this frequency dynamics to assess inertia of system and its impact on your primary control, secondary control, tertiary control activities is something which is really very important for every stakeholder to take care of. And then to have this point of to prove this point of view and to prove this concept, we have come up with a case study where we demonstrated this inertia profile and understanding inertia profile, nature of volatility of inertia profile by this particular case study, where there is a certain percentage of conventional generation serving certain percentage of load. And then that becomes a kind of a conventional system. But anyways, conventional system is really not the system which we see every day today. We do have a second case where there is renewable, presence of renewable. So assuming every generation to be a kind of a conventional generation, this is what is going to be the kind of inertia profile of this network, where inertia at every load depend on what kind of generation there is, what is the capacity of generation, and then now you can evaluate the inertia of that particular node. Now, why the calculation of inertia is important, the way we anticipate load and the way we anticipate load curve and load profile. Here, this inertia is now becoming more volatile. That's mainly because of presence of renewable at certain say locations. So when we replace and when we are going to think of renewable as an alternative to conventional generation, compensating for conventional one, then in that case, if you see couple of nodes, when they get replaced by renewable, the inertia offered at that node will be negligibly small, or we can assume them to be zero. So the moment we say they are negligibly small or near to be zero, you can find difference in the inertia profile in terms of magnitude, as well as which nodes are more sensitive in terms of becoming vulnerable. Now, why understanding inertia is important? Because there is being a dynamic in nature, system being dynamic in nature, obviously we say that there are natural perturbations, and system is going to behave or react to these perturbations in terms of having frequency, rate of change of frequency. So having certain percentage of perturbation, you are allowed to let your frequency to vary within certain bandwidth. But having this unknown perturbations in terms of generation availability along with load availability, now what's going to happen in this system is the inertia is again becoming more and more, what you can say, volatile. And that's why these are no more going to become constant. You really need to seek eye on the variations in the inertia profile. And then this variation in the inertia profile, you can make use of in understanding and assessing the capacity of this grid to get back to normal in terms of evaluating perturbation sustainability level. So first thing which we come across is like this impact of perturbation on frequency would be the inertia. You have to evaluate at every node. You need to understand variation in the inertia at every node, and then it can help us understanding the overall sustainability aspect of grid in terms of resiliency, in terms of getting back to stability. So when we talk of stability, the way now we assess steady state stability, transient stability, say dynamic stability, we really need to take into account this impact of inertia also while evaluating stability and the time which it will take to come back to its stable state. That is one. And when we want it to come back to its stable state, the very important factor that one should know is the inertia profile which is available nearby nodes, so that we came across how much should be the magnitude of support which is required at certain nodes if we want system frequency to get back to 50 Hertz standard value within given minimum time, so that none of our switch gears will maloperate. So for that case study here, we have got a certain representative inertia profile which talks of certain nodes having inertia available with them and certain nodes where they need inertia. So getting this such visibility about the network in terms of node dependent inertia, variations at node dependent inertia, and then magnitude of inertia available at that node whenever there is certain amount of perturbation. Now the logic which is applicable to perturbation, the logic is same applicable to even fault conditions also. The difference is during fault conditions, the severity of movement and flow and penetration of the impact will be larger compared to normal dynamic penetrations which happen because of, say, load change. So when we get this visibility around inertia profiling and the requirement of support at certain nodes, then there are so many ways by which utility and the stakeholders would be ready to support that inertia so that system will be resilient. That can be done by immediate, say, power support. So when we talk of an immediate power support, today we do see the trend of utilities investing into DER, even coming up with a backup support. So you can have a hybrid system of storage where you can take care of this intermittency and its impact on frequency as well as inertia support. So that is one indicative way to do that. The second indicative way is understanding your system, understanding generation availability at your grid, understanding the static and the dynamic behavior of the system. It is very well to be defined in terms of infrastructural changes that have to happen in the system. So it may happen eventually understanding the penetration of DER along with growth of load in your area and even availability of generation from conventional sources. One can think of having a parallel transmission line taking care of this flow of power, uh, minimizing the inertia impact and even maximizing the sustainability and resiliency of the grid. So in short, what we need to do under this scenario of green energy technology is to really understand the side effects of DER and then literally work on them in terms of techno-commercial, from the point of view of techno-commercial aspects, so that ultimately it is going to, help us by providing power, which is green power, even while, providing more visibility about the grid and more visibility towards the challenges where operators really have to be proactively ready for such sort of a challenges. So that was some sort of a thought process behind presenting this paper at this platform. At the end, I'm thankful to India Smart Grid Forum for giving us this opportunity to share our point of view around the inertia, impact of inertia because of DER penetration into smart grid and how data can play a very important role. the kind of a marathon that I have run, but
No, I think that thanks a lot, Dr. Surekha, and even for maintaining the time slot. Any quick questions? I think Mr. Madanlal has rather given comments than any questions. So unless we have any questions, can we move to the next speaker? I don't see any questions. So okay, let's move on to the next speaker. And our next speaker is Mr. Krishna Porwal from Tata Power DDL. Over to you, Paro.
Thank you, sir. The next presentation is for the paper Unified Regulatory Management for Utilities in Smart City, Common Utility Alliance by Mr. Krishna Porwal from Tata Power DDL. Mr. Krishna has 5 years of experience in DISCOM operations and maintenance and currently leading electric vehicle private charging infrastructure deployment in Delhi. So over to you, Mr. Krishna.
Thank you, ma'am, and good afternoon, everyone. And thanks for providing me the opportunity to present my thoughts and ideas. So I would just be sharing my screen. I hope my screen is visible and I am audible.
Yes, we can hear you.
Thank you, ma'am. So, sir, as we all know that while working in the DISCOM, we have come across one of the challenge, that is the involvement and working and functionality of multiple utilities in a city. So when we talk about smart cities, we focus on improving the systems for the consumers, improving the system for residents, and more and more reliability in terms of power system networks. So there are multiple utilities like PWD, municipal bodies, gas agencies, water utilities working in the city limits, and they all perform their day-to-day operations to deliver the quality services to the residents. So currently, when we look, all the utilities are working in the standalone, and they are guided by their respective regulations and standards. So if we look after that, any new development that is being done in a particular area that is independent of any other concerned utilities that is involved into that area, or any new projects that the other utilities are having in their particular area. So due to this like segregated functioning of the utilities, there are multiple challenges that are being faced by DISCOMs, and the network damages that are being incurred by the DISCOMs due to the uncoordinated functioning of the utilities within the city. So,
Mr. Krishna, we can't see your slide.
Yes, sir.
Maybe you can stop sharing and reshare. I think I see a white blank screen.
Sure, sir. I will reshare it.
Yes.
Sir, is it out visible?
Yeah. Now it is visible. Absolutely.
Thank you, sir. Thank you so much. So, sir, the power distribution companies in the work in achieving the two main goals, that deliver the low cost power and reliable power to its consumer, and deliver the like in the upcoming system, we are the consumers' expectations are rising, and they are also looking for the better reliability along with the quality of power that they are getting through their at their premises. So financial viability and commercial disciplines has always been a challenge for the utilities, and we all know that the DISCOM assets like the power lines or transformers or the service lines, poles are deeply penetrated into the city all around, and within a city, if the segregated functionality of all the utilities, like we count like PWD, municipal bodies, gas utility, water utility, if they are working segregatedly, independently, so the network damages that are done to the DISCOM network, which is deeply penetrated and widely spread within a city, are high. Working into the DISCOM, we have faced multiple challenges regarding the haphazard conditions of our distribution network, damages of poles, and regular damages of the underground cables that are being done. So all these are the challenges that DISCOM faces in its day-to-day activities and functions. So if we look into the data of last 5 to 6 years, then we can find that around 300 to 400 damages are the external damages that are being done to the underground network of a utility. So if we look into the like north and northwest part of the Delhi, so 85% of the 11 kV network is underground. So and also from like the 11 kV is directly transformed using a distribution transformer and is fed to the power is fed to the consumer. So its penetration is laying is also done all around the city and till the consumer premises in the HVDS network as well. So the such 300 and 400 damages to the cable are very high for a DISCOM, and on an average you can say that each day a single cable is being damaged in the DISCOM. If we look into the reliability impacts of this only underground cable damages, so only due to these external damages of the underground cable, a DISCOM accounts for like 6 to 7% of their SAIDI and SAFI. So the impact of just the underground cable damages is huge, and revenue, if we talk about the unit loss that could have been sold out the unit due to if the power reliability have been maintained, so it accounts to around 3.5 lakh units every year. So and it's not just the underground cable damages due to the functioning of the other agencies. It's like suppose in the in our distribution area in the Badli DSI DC has done a cement road work. So it was not communicated timely to the DISCOMs, and during the execution, even after the regular follow-ups, when the work has been completed, you can see that the all around the transformer and the fans and gate has been blocked. So in any case of any interruption that has been occurred, or if there is any emergency situation, then entry and exit to the substations has been blocked. Similarly, the underground cable damages that are being done by the road agencies during their road repairing work, or if there is a new path cycle tracks coming from, like we are talking about, we can see that currently from Rohini to Netaji Subhash Palace in the north Delhi, there has been a cycle track coming up. So in the last 1 year, we can see we have experienced multiple damages due to that particular section in all our underground 11 kV network. Similarly, there is one case we have experienced in the Buradi area where the INFC was performing a road widening work. So in that also you can see in the third image that all the mud and the widening of the mud that was laid for the widening of the road has completely blocked and surrounded the electrical substation. So this damage that is being done to the DISCOM network are not being incurred into the development project that was planned by the performing utility. Similarly, if we looked at water logging, and these are some of the regular challenges that are being faced by the DISCOMs, and the damage to the DISCOMs asset is high. So that there was one observation that I have captured and tried to record into a video. So we are all aware that in the Chandni Chowk and in the Karol Bagh area, Delhi government has done in the past few years, they have done a redevelopment work and beautification work into the area. So first was the Karol Bagh area that was done by the municipal board, by the Delhi government, and I paid 2 visits to that particular locality. So when the work was done at the first time, the image was looking very beautiful, that all the bricklaying and road widening has been done. But in a coming 1 or 1.5 year, when I revisited that place, I saw many potholes that I would be sharing you in the next upcoming video. So, sir, this was one of the observation of that we have taken from the Karol Bagh beautification and redevelopment that was done by the Delhi government in past in few years back. And if we can see the current scenario over there, so whatever the work that was being done due to the repetitive work of multiple agencies after completion of the work, the actual asset that was created into the redevelopment has been damaged several times, and the purpose that was meant to be like to provide a beautiful layout to the market has been not been achieved right now. We cannot see that now. So it results into wastage of resources of the performing utility as well as the other utilities. The projects get delayed due to multiple agencies being involved. Repetitive work has been done into a particular area. It also impacts the consumer services and availability of the resources to the consumers. And also it increases the financial cost of the projects. So along with, it's not just the projects that are being like, if we talk about, it's not just the damage of the assets, also the independent working of the multiple utilities within a city also impacts, also results into creating an unsafe situation for the consumers. Like if we talk about, if we can see all around the Delhi, the street light pillars, like I have captured in the first image, you can see that the doors of the street light pillars are open, the bus bars are naked. So it can be a very highly unsafe situation for any residents around it, and it can anytime result into a major accident. Similarly, during the INFC work that I was sharing, so we have captured that the utility performing the installation of the light just used a hydra and climbing on that, and because the manpower that was performing the task is not an expert or any, it is not their major operations or day-to-day activities. If similarly the if we talk about like the distribution of activities in a city is distributed as per the land owning agencies. So if it's a PWD road, so street light work or any other work would be done by PWD. If it is a MCD road, so it would be done by MCD. Or it is a DSIDC land, so all the work responsibility is being assigned to DSIDT. And there is one more catch in this, that sometimes they, based on the land ownership also, there is a demarcation of road ownership. So if the land is owned by DSIDC and if the road is owned by some other agency, so there is no a set demarcation of the activities, that who would be performing the cleaning of the sewage lines, or who would be performing the maintenance of the street light poles, or who would be paying for the energy consumption on the street lights. And we are all aware that in the national city that we are sitting right, operating, and we, even a small minor rain results into a waterlogging on all the streets and underpasses. So this is all because lack of maintenance. There is no particular demarcation of the duties that are being, that has to be done to a particular single utility, and also to that utility who is expert in a particular job. So like in the last image, you can see we have experienced in the Wajirpur industrial area for the past 3 to 4 years. There is a demarcation in the duties of the land and road. So the street lights once get faulty, there is no defined that who would be paying for the energy cost of the street light and the maintenance and repair cost of the street light. Due to there is no, this is because of absence of any demarcation of the duties. So the formless distribution of ownership and service leads either leads to non-execution or overlapping of the duties. Also, if a project has been executed and it was not communicated to the other utilities, and if they come to conduct that particular activity again on a particular area, so that recurring development works results into the damage of the previous asset that was created into that area. Further, the damage reduces the asset life and integrity. Also, due to unskilled work or a lack of expertise, quality and safety, there has always been a major challenge for the India's utilities. Also, the lack of synchrony between utilities impacts project life and increases the financial cost of the project. So, what can be the solution towards this? So if all the utilities that are being operated in the city, they have been guided by their respective regulations and management. So in a smart city, if we can ensure that, if we can develop a mechanism or a framework where there will be a single regulatory management of all the utilities, which can regulate, advise and govern all the utilities, this will definitely going to help and improve the services to the consumer, reduce the cost, reduce the lead time of the projects, and improve the cross licensing between the utilities working into the area. So what can be the framework for the utilities that are being functioning? Like if a principal utility that has to perform a particular project or develop a particular project in a particular area, so it would be preparing a report and submitting it to the apex body. The apex body will communicate this to all the concerned utilities that are involved in a particular area, and all the concerned utilities will be performing a joint site visit and prepare their and assess the assets that are present, their assets that are present into that particular project boundary, and they will assess the impact that is going to be done on their assets. They can analyze that if in the upcoming 2 or 3 years, is there any upcoming projects that they have to do in that particular area. So this all can be decided into a joint site visit, and this further all the utilities can prepare their proposals and submit to the apex bodies. Finally, the joint objective and goals and responsibilities that has been received and would be demarcated by the apex body. So this this will also ensure that the permissions that are being catered by the DISCOMs that are received smoothly, the project lead time would be reducing, and the financials involved of a DISCOM into a particular project will be reduced. So there is one of the case study that I have included in it. So like we were saying that in INFC was performing a Pushta road widening work into the Buradi region. So what they did, there was a single lane road. So during the after the government announced the project, it was not discussed with all the utilities involved in that particular area. And as you can see that the poles that are after the road mud laying and all was done by the INDC. This is the image captured after the mud laying process. And since the project was started, DISCOM was we were in regular touch with the INDC department, but the network shifting and the cost involved was not provided before starting of the project. So it resulted into that all the assets of the DISCOMs were in between the roads and severely damaged. So if inclusion of all the electrical communication data, water, gas utilities was done at the project planning stage, and whatever the cost was involved, it was included at the earlier stage. So when a particular INFC was performing a task into that road, at the same time, electrical, water or gas utilities could have done their development projects or shifted their networks from that particular road without incurring any damages. And also the consumers would have to suffer only once for a particular period, and there would not be any recurring development work. So like the current scenario is that the Pushta road has been constructed, but still the electrical network is as it is that was there. So we have the later on at the completion stage, we have received the fund from the INFC for shifting the network. So now what electrical as a DISCOM, we would be shifting our network from the mid of the road to the side space provided. So we, during that process, again, we would be cutting the roads, laying our underground cable and all the sorts of work. So the road that was built like 2 to 3 months back would be again damaged and reconstructed. So this is the recurring development work also will be reducing the life of the road that was expected during its construction work. So these are the key, what are the key, all the utilities if the governed by should be governed into the smart city by apex body. On a regular intervals, a single all utility meets could be done where they can where they would be discussing their projects, what are their upcoming projects, and what are the utilities that are going to be involved, what other utilities can assess their asset damages and submit their proposal into that meeting. The utilities must ensure that combined execution or development work is being done by them. The cost of network planning and revamping of the affecting utilities must be included at the planning stage. And within a city, each service role must be defined to a single utility only. So currently, the demarcation of the duties is done based on the land owning agency. So it is not a efficient process. And if if a DISCOM is having expertise into all the electrical network, so street light maintenance across the city could be provided to DISCOM so they can better manage it and ensure better functionality. Similarly, all the underground water, underground paths that are having motors for drainage of the water that is being collected over there. So that can be provided to the DJB there because they are having expertise in the motor operations, day-to-day operations. Similarly, all the if we are talking about sewage cleaning, so it would it should be provided to a single utility that is having expertise in that particular operations, and that is their core operations. So this will ensure that the quality services, efficient services are delivered to the consumer. So thank you everyone, and thank you for providing me the opportunity to share my thoughts about the common alliance of the utilities into a city.
Mr. Narang, you are on mute.
Oh, sorry. So I think very well presented the case, and I think this is where smart cities can really play a role. And the way I understand, we already as per the smart city plan across all the 100 pilots that are going on, we have an integrated command control center, and the role of that integrated command control center is precisely this very much that all the different agencies, are well coordinated. There's a proper digital, dashboards for monitoring, maintaining, controlling, and passing on the information to relevant stakeholders to take care of their own obligations as and when there are any new requirements, new changes, maintenance, or whatever is needed. I think, but very, very interesting and very relevant paper, I must say, and in context of the theme. Any questions from the audience? Yeah. Go ahead.
Sorry. Krishna has raised very good points, but the issue is he is talking only of smart city. We have been in this job in electrical engineering for 50 years, 60 years. I myself have been 34 years in the government service. And there, many ISS are there, manuals are there, I rules are there, which says how to lay the cables. The compliance is not done. Major is how to make the utilities, contractors, and other people to comply with the rulings. It is clearly said that 6.6 meter or 0.65 meter below the ground shall be LT cable. The cable markers are to be put, but nobody does it. Neither inspector check it, nor the contractor do it. Then similar under smart city, if you want to give a good quality power, why not to the other people also? The other cities area which are not. So this compliance or rule shall be made mandatory, that no even independent, either an inspector or a client, consultant or anybody, they shall go and give a certification, or institution, CPRI or ICRC, and they shall give a certificate that things have been done properly. This is my suggestion.
Yeah, definitely, sir. I agree with your point, and it's not like that 100% laying is being done correct by the DISCOM only. But the point, your point is very well taken, and we agree with that. But the point here is like if, let's say if there is 20% laying has been done as per the plan or as per the guidelines, still if after laying of the cable there has been development work again by some other road agency, so they would be damaging the route markers that are placed on that particular length stretch of the network. So there is no such accounting for that damages that is being done on a regular basis.
Gentlemen, in UK, for every water system, for every cable, the route has been clearly identified. Nobody can interfere into laying or operating this thing. The similar situation not possible in India, but some precautions can be taken care of.
Absolutely. So I think Mr. Sadeo, what you're saying is right. The frameworks are there, mechanism is there, but implementation and compliances are where we need to make our, municipalities, our different civic agencies wake up and take note of it and work in a more concerted manner. Whether it's a smart city project or any normal city, I think these are some of the basic foundational principles that each civic infrastructure utility or organization agency needs to look at and make sure that there's a structured and comprehensive granular approach to maintaining this. Otherwise, all these kind of issues will continue cropping up, which we have been already witness to in last so many decades as part of our daily life in our cities. Absolutely, I think very relevant topic brought in, Mr. Krishna. Thank you very much. Any question? Anybody else has any questions? Any other attendee? If no, then I think because we have other papers pending and we are already running what 25 minutes late. So I think I would like to close this session and hand it over to the next chair, Mr. Yeah.
I raised one issue to Sulekha, mentioning this thing, that these studies which she are talking of inertia or the frequency restriction, who's to do? Is it a contractor to be made responsible? It is the utilities to make to be responsible. But the expansion is going in such a way that it will not be easy till you reach at a certain stable condition. These studies are complicated studies. Every data of the machine, turbine, or this thing has to be furnished by the supplier.
True.
What is the
Absolutely true. And that's the challenge today that we all are facing, is that we really do not have that granular information available with us, even having this prosumer penetration. The way now integration of power is happening at low voltage side, certainly it has got an impact on entire electricity value chain. Important is like how to, at least we need to make a word of this, that we really have to monitor our network, which used to be very robust. Now that network has become very sensitive. So do ready for all the corrective synthetic inertia support. Because a coin has two sides. As we talk of a glorified part of a renewable, we really need to address the second side also. And then T&D, transmission, distribution, ecosystem, as well as even it comes down to a prosumer category. It comes down to that level. Because everybody of us is contributing to that inertia because of this such what you can say, low magnitude power ingestion, or presence of power, I should say, not necessary ingestion, but generation of power at such a low voltage and low power capacity being happening in the grid in life. It certainly has made our grid more sensitive compared to the previous grid.
Yeah.
That's why
inertia was not a problem in the past when you have a conventional system, right?
Correct.
Now this is a third issue. This is another issue which has come up. We used to study on the system study, which was dynamic over voltages, switching surge, lightning, and after doing a proper designing, we were doing it. But now the inertia has become another issue, and which is going to overrule the others, because frequency variation is with reference to inertia.
Absolutely. That's something which really we wanted to put this on piece of paper so that people will think of it and, come up with some sort of a roadmap of action, sir. That is very much required. The primary control, secondary control, tertiary controls of huge power plants. Now, such power plants, they do not exist to that, percentage, what I mean to say.
Absolutely.
Very valid operational challenge.
You have to cultivate this habit now.
I think the point is very well taken. I think I'll suggest further discussion to be held offline because we are running late in the session. I'd like to hand it over back to Parul and to the next chair, Mr. Vijay Sonavne. Thank you, Parul, and thank you, ISGF, for allowing me to chair the session. Thank you. Thank you very much.
Thank you so much, sir, for chairing the session. And thank you to all our authors for the presentations and the discussion. So we'll move ahead with our next theme. I'll just quickly share my screen for that. So we are starting with the theme New and Emerging Technologies and Trends. And the chair for this session is Mr. V.L. Sonavane. Mr. V.L. Sonavane is former member MERC. Prior to MERC, sir has worked in various capacities in Maharashtra State Electricity Board and has worked on many special cases and has presented and published over 40 papers in various national and international conferences. So I would like to hand over the stage to Sonavane sir in case he wishes to say a few words. Sonavane sir, you're on mute.
Hello. Hello.
Good evening, sir. Sir, good evening, sir.
Very good evening. Very good evening. Thank you, madam. And since we are late, I think we'll start with the first paper from Ms. Shalu Agarwal. Hello. Hello.
Sir, I would like to inform that Ms. Shalu Agarwal will not be presenting the presentation today. Mr. Sunil Maini will be doing the same.
Okay,
And
madam.
I will quickly give a brief about Mr. Sunil, and then we can start.
Right, madam. Right.
So the first presentation for this theme is for the paper "Are Indian Homes Ready for Electric Cooking? Insights from the India Residential Energy Survey (IRES) 2020" by Mr. Sunil Maini from CEW. Mr. Sunil works as a researcher at the Council on Energy, Environment and Water. He holds a deep interest in studying the energy access and efficiency issues and the social and economic effect of policies that target this intervention. So with that, over to you, Mr. Sunil.
Yeah, thanks, Parul, for the kind introduction. Is my screen visible? Hello?
We can't, it's showing that it's loading, but we can't see the screen yet.
Okay, maybe I'll try to share it again, perhaps.
Yeah, please do that.
Yeah. Is it still not visible?
It's visible. It's visible.
Oh, sorry. I'll try and share it again. Yeah, hope it is clear now.
Yes, please go ahead.
Thanks, Shalu, and thanks to Mr. Sunavni for chairing this session. Hello, everyone. I'm Sunil. I work as a public policy researcher at the Council on Energy, Environment and Water. And today I'm going to share the findings on the state of electric cooking in India. And based on these findings, we'll try to understand if Indian households are even ready for electricity-based cooking. One of the reasons why this analysis is important is because the government of India launched the Go Electric campaign last year to spread the awareness on the benefits of electric cooking. And this is, of course, an attempt to make the electric cooking a mainstream clean cooking option so that the LPG import burden on the country can be reduced. However, before scaling up electric cooking, it is also important to understand the current extent of its adoption and use in the country and whether it is cost effective compared to other clean cooking alternatives such as LPG. It is also important to understand the perception of households about switching to electric cooking compared to their current cooking fuel in terms of its feasibility, ease of use, and affordability. And as Parul highlighted, we have used the data from the India Residential Energy Survey or IRES 2020, which is a nationally representative household survey to answer all of these questions. And we at CW conducted this primary survey in the year 2020, and it was finished right before the pandemic in March 2020. So, yeah. Yeah, so about my organization, CW is one of Asia's leading not-for-profit policy research institutions. We have 7 key focus areas in total and a Center for Energy Finance at the Council. At CW, we use data, integrated analysis, and strategic outreach. I
think somebody's mic is on. Somebody's mic is on. Yes.
Sir, nobody's mic is on. Only Mr. Sunil Maini is speaking.
Why I'm getting two sounds. Echo like.
Okay, but sir, it's coming fine to us. I'll just mute myself. Maybe it's something with me.
No. Okay. All right, yeah. It's all right. Please go ahead. Sorry, okay, very sorry.
Thank you.
Please go ahead.
Thank you. Yeah. So before I come to the key highlights from our study on electric cooking, I would like to briefly share details about the IRIS 2020 survey. In IRIS, we surveyed 14,850 households, one third of which were from urban India and 2/3 were from rural India. And this map shows the distribution of the districts covered in the survey, and also shows that we cover households from almost all parts of the country in this survey. And these were a total of 152 districts from 21 most populous states of India. And we relied on multi-stage stratified sampling for our data collection. Um, just to inform you, using IRIS data, we've also published several comprehensive reports on household electricity access, energy efficiency, and clean cooking energy access in the country. And we've been using these reports to engage with various line ministries to drive the change. We also launched the IRIS unit level data for public consumption on Harvard Dataverse last year, and it is available for free download to everyone. And I have shared the link to download the dataset as well as all other IRIS publications on the last slide of this presentation. So I'm directly moving to the findings on electric cooking in India. So from IRIS, we find that only 5% of Indian homes use an electric cooking device in India. And as represented by the red dots here in this graph, the penetration is higher in urban India at 10.3% compared to 2.7% in rural India. And as you can see in this figure, households use diverse electric appliances for cooking their food, starting with induction cookstoves and rice cookers for cooking staple foods, to microwave ovens and grillers. However, induction cookstoves and rice cookers are the most popular e-cooking appliances, each used by nearly 40% of the electric cooking users. And this is followed by microwave ovens, which is owned by 1/4 of the e-cooking users in India. So on this graph here, we have wealth deciles on the x-axis. And as you can see, the use of e-cooking is concentrated among wealthier households in India. In fact, around 85% of the e-cooking users belong to the top 5 wealth deciles, which suggests that household economic situation plays a vital role in the adoption of electric cooking devices. We also did this analysis at the state level and again found economic factors to be playing an equally important role in the adoption of e-cooking. At the state level, we find that Tamil Nadu and Delhi have the highest proportion of e-cooking users in India. Apart from that, Telangana, Kerala, and Assam were the other states where at least 1/10 of the households used e-cooking appliances. Apart from the role of urbanization and economic status, we also tried to understand the other potential determinants of these differences in electric cooking adoption rates in different states, and power tariff rates emerged as an important factor in influencing the adoption of e-cooking. For instance, Tamil Nadu, which has the highest e-cooking adoption rate in India, provides heavy subsidies on residential electricity consumption. Similarly, in Delhi, households consuming less than 200 units per month receive a 100% subsidy. And in fact, recently, various other states have also announced free electricity for a certain category of households. So we might expect to see an increased adoption of e-cooking there as well. We also found some correlation for e-cooking adoption with payment discipline. For instance, in Assam, that has the 4th highest penetration of e-cooking, we found that wealthier households use appliances like rice cookers or microwave ovens because they can afford it, whereas low-income households in Assam used electric coil-based cookstoves because they are cheap. And we also looked at the electricity bill payment behavior of these electric coil users in Assam and found that most of them could neither recall their electricity expenses nor did they possess a copy of their electricity bill at the time of the survey. So clearly there is some relationship between electricity payment discipline and the adoption of electric cooking, but it of course needs to be researched further. But all in all, our analysis suggests that future adoption of e-cooking would likely be higher in states with lower power tariffs or in states with gaps in billing and revenue collection, which is certainly not an optimal outcome for the DISCOMs. Now, since Indian cooking energy space is already dominated by the LPG, and 71% households already use LPG as their primary cooking fuel, the next logical step was to understand if e-cooking is cheaper or expensive compared to LPG. So here we present that comparative analysis. As you can see, the red upward sloping line shows the monthly expenditure of exclusively using electric cooking at different per unit tariff rates for electricity. And we've arrived at this monthly expenditure curve using an assumption from the literature that a typical Indian household will use 974 units of electricity in a year if they only use electricity for all their cooking needs. And similarly, different horizontal lines on this graph show the amount of monthly expenditure required to exclusively use LPG for cooking at different LPG refill prices. Here we have assumed that exclusive LPG users would need to use 8 large LPG refills, which amounts to around 114 kg of LPG in a year. And when we were doing this analysis, the price of LPG refill was around 800 rupees in India, which is reflected by the black dotted horizontal line. And a typical exclusive LPG user needed to spend around 540 rupees every month at this price. But now the price of 14.2 kg LPG refills have touched 900 rupees in India, which would increase the monthly expenditure requirement on LPG to 600 rupees per month. And extrapolating these lines to that level show that at LPG price of 900, e-cooking will be cheaper than LPG for all the households who are paying a tariff of less than 7.4 rupees per unit. So this is a key message from here, that e-cooking will be cheaper than LPG if per unit electricity tariff is less than 7.4 rupees per unit. And in India, the average per unit tariff for residential consumers is only around 5.5 rupees. So basically, this brings us to the question that while e-cooking is operationally cheaper, why are households continuing to rely on LPG as their main cooking fuel? And one important reason is that one will have to spend around 4,000 rupees on purchasing the e-cooking devices and compatible utensils. The same high upfront cost was also the barrier with LPG until 2016, when the cost of taking an LPG connection was around 4,000. But it was solved by the Pradhan Mantri Ujjwala Yojana scheme, which provided the LPG connections to the 80 million poorer households at no upfront cost. So now going back to the same picture that I had shown separately to compare LPG versus e-cooking, and coming to the next slide, basically both these images were actually from the same home when both of them were getting used simultaneously at the same time. And if you notice that they are cooking chapati on the LPG stove and something else on the induction stove. And this is mainly because it is difficult to cook chapati on the induction stove. And this is the reason why even at an all India level, we find that 95% of the electric cooking users also had an LPG connection, and 92% of them relied on LPG as their primary cooking fuel. We also found that half of the electric cooking users, only half of the electric cooking users basically used electricity for cooking on a daily basis. And that too only for some of their cooking needs. And these variations in cooking appliance usage patterns will have a significant bearing on how the uptake of electric cooking in future will interplay with the demand for LPG. This suggests that while e-cooking is cost effective, it needs to be more adaptable to Indian cuisine. So until here were the usage patterns among e-cooking users, but since 95% of Indian homes are yet to use electric cooking in India, it is also important to understand the current perception of non-users of electric cooking, because I mean only then we'll be able to say whether electric cooking is going to be scaled up or not, and then it also needs to be compared with the perception of the electric cooking users. So to understand the household perceptions of relying entirely on electric appliances for cooking, we asked them the 3 questions on different aspects of e-cooking. First question was, would it be feasible or not to meet all their cooking needs using e-cooking? Second question was, would e-cooking be faster or slower than the other alternatives? And the third question was, would it be cheaper or costlier than alternative cooking fuels? And we show the responses separately here by grouping the users and non-users into 2 groups. And as you can see, among e-cooking users, nearly 60% agreed that it would be feasible to transition to e-cooking entirely. And an equal share believed that e-cooking would be faster than the alternatives. However, only a third of the users find that e-cooking will be cheaper than the alternatives. And this is perhaps because most e-cooking users are high-income households who also pay higher electricity tariffs, because they might be falling in higher consumption slabs. On the other hand, as you can see, a significantly higher proportion of households that are non-users are either skeptical or uncertain about the benefits of e-cooking. And this significant perception barrier between the users and the non-users would influence the pace and scale at which Indian households are likely to adopt or use electricity for cooking in future. And this certainly needs to be addressed through the campaigns like Go Electric. We also did an assessment of perception of non-users falling in different wealth deciles, and found that non-users that are relatively wealthier showed a relatively optimistic outlook about e-cooking. This perhaps suggests that higher income households would most likely be the first to switch to electric cooking, and the pace of this transition could be higher in urban areas of those states which have lower power tariffs. Rise in power demand is another dimension that is important to consider when we talk about promoting e-cooking in India. And while the current penetration of e-cooking is only 5%, we expect that more and more households will adopt e-cooking in the future with increase in awareness about the appliances, changing lifestyles, and access to reliable and quality power supply. So we assume an aggressive shift of households to e-cooking as their exclusive cooking fuel, which is 25% in 2030, 50% in 2040, and 100% in 2050. And accordingly, we find that associated power demand would rise by 82 terawatt hours in 2030, 174 terawatt hours in 2040, and by 359 terawatt hours in 2050, as per these assumptions. We also looked at the overall estimated power demand in 2030 and found that with 25% household shift into e-cooking, the additional electricity demand for e-cooking would be 3.6% of total estimated power demand in 2030. However, what is more important to highlight here is that the additional peak demand would rise by 101 gigawatt, and which will amount to around 14% of total estimated installed capacity in 2030. And such significant rise in peak demand may have substantial implications for grid stability and flexibility. Similarly, if 100% of the households shift to exclusive use of e-cooking by 2050, this peak demand would rise by 442 gigawatt in 2050. In fact, even if 85% of the households shift to e-cooking by 2050, we will need to increase our load capacity by 375 gigawatt compared to current installed capacity of 3 gigawatt, so which is more than double of India's current installed capacity for grid. However, these are all preliminary assessments, and for actual assessments, we are planning to do some simulations as well. However, what is clear is that in order to ensure reliable and quality electricity services to enable households to rely on e-cooking without a backup, we will need to significantly add to the grid infrastructure to support the rise in peak demand. So just to conclude, the uptake of e-cooking is currently limited to only richer households in the country. Some households have greater uptake because of different drivers, but affordability remains a big barrier in its adoption almost everywhere. So it remains to be seen as to how households make their choices going forward between LPG and electric cooking. Because with LPG, we have high recurring expenditure as the barrier, but with electric cooking, we have high upfront cost and perception barriers. So here are the recommendations from our study. Electric cooking appliances are expensive, and government will need to incentivize R&D for low-cost electric cooking solutions so that even poorer households can become equal participants in this clean cooking energy transition. Since upfront cost is a big barrier, we also need to devise innovative financial solutions, such as offering loans at attractive interest rates and payment options that can stimulate demand for e-cooking devices. We also need to improve the adaptability of e-cooking devices so that it suits the culinary habits of households from different cultural backgrounds, but we'll again need research and development to address this issue. We also need to ensure reliable and quality electricity services to enable households to rely on e-cooking without a backup. Even though power services in India have improved significantly in the past few years, many households that we surveyed in IRIS reported that they still face issues like unpredictable power outages, occasional extended blackouts, and voltage fluctuations. We also need to conduct in-depth studies to capture the household experience and perception of e-cooking under diverse social contexts, which in turn could help guide future policy interventions related to electric cooking in India. And again, CW is planning to conduct some of these in the coming times. And finally, as I discussed in the last slide, we need to continuously monitor the rising electricity demand due to rise in e-cooking penetration, especially because the demand from e-cooking coincides with peak demand from electricity in the morning and evening hours, and that will significantly increase the load requirement. So that's it from me. Thank you very much, and I would be happy to discuss this further. If you have any queries or suggestions, please contact us at the given email IDs. And I've also listed down the links for downloading various IRIS publications and IRIS data there. Yeah, thank you.
Thank you, Mr. Sunil.
Yeah.
Firstly, because giving us an idea of e-cooking and giving all relevant details as well as what sort of studies you are doing and what sort of studies need to do in future. If there are any questions from the participants, I would like to invite them. Hello.
If any participant, if any author have any queries, they can write in the chat box or they can unmute themselves and ask the question. And if they have any query later, so they can always write in the chat box. I request our presenters to answer the queries in the chat box itself.
One query. See, they shall not recommend subsidy for use of power for e-cooking. The main reason is that already utilities are in red.
That's
Further,
right.
adding this subsidy will make their status. They are also be asked to be closed down because there are many people saying discoms are no good. They shall be all closed down and made private sector. Now, how private sector is going to meet the subsidy? And if unless the central government again gives the money, so this way manufacturers shall give on lease the devices, or the cooperating agencies shall give them on lease and take back the money from them. Thank you.
Thanks, Mr. Satsiva. That is a very, very important point that you've
That's
highlighted.
correct. That's
Yeah.
correct. That's correct.
Yeah.
Yes.
Yeah. About subsidies, I think because the reason in India is, I mean, because most of the households are still relying on traditional solid fuels as their cooking, basically primary cooking fuel, and that has huge health implications as well.
That's right.
So which is why I mean, of course, you're right that discoms, of course, are not in a position to subsidize this consumption. But maybe if you know, because central government was already subsidizing LPG up until now. So if that subsidy can be shifted from LPG to electric cooking from central government side, that can be one of the things that can be explored. But yeah, I mean, I completely agree with your suggestion on this. Yeah.
The subsidies are spoiling India. If you ask me, people who really want subsidy, they will not get it. The people who do not want, they will get the subsidy. So this has to be taken. Forget about subsidy. Don't talk about subsidy. Where water subsidy, electricity subsidy, 200. Why Delhi shall give 200 unit free? Is it Delhi is not in a position to bear the charges for the electricity? Why Kerala shall give free? And this is all totally. Sorry, I'm straight.
No, it's right. You are talking the truth, but yes, we are living with this problem, or we are living with these issues.
Now, how long you will live?
That is right. That is right. We'll have to. Somebody will have to. In fact, the regulators themselves can put some sort of control on this. That is cross subsidization, reducing the cross subsidization. And if you'll ask me, yes, some regulators are doing or working towards that, but the government
Tata
comes
is
inside.
Tata is giving at the low rate power, which is fixed by the government, and they are asking to refund the subsidy. They are also not getting. CSC is also not getting. How the people, how the contractors or the suppliers can bear all these things?
That's right. That's right. That's right.
So now, Vanessa, shall we move to our next presentation?
Yes, madam. Yes, madam. I think the next paper is by Mr. Kumar.
Yes,
Mr.
sir.
Kumar. Yes.
Yes, sir. So the next presentation is for the paper Combustion Modification, Implementation Challenges and Impact on Boiler Performance with respect to Indian context. And it is by Mr. Kumar Skand and Mr. Pankaj Kumar Gupta from NTPC Limited. Mr. Skand is responsible for the design and review of the boiler and auxiliaries equipment and responsible for preparing the technical specification for the steam generator, boiler auxiliaries like fan, air, preheaters, etc., electrostatic precipitator, air pollution control system like flue gas. selective catalytic reduction system like that. And Mr. Pankaj Kumar Gupta is working as General Manager in the Project Engineering Mechanical Division of NTPC. Sir has more than 30 years of experience in thermal power plants in the area of engineering and operation and maintenance of steam generator. So over to you, Mr. Skand and Mr. Gupta.
Thank you, sir. Thank you, Parol, and thank you, Chairman, sir, Mr. Sonawakar. I'm Pankaj Gupta. So just I wanted to introduce that MOEF introduced new norms in 2015, December 2015, and revising the limit for thermal power station for the SO2, NOx, SPM, and mercury. So after that, it was found that many plants impacted, which is existing power plants, has been impacted by this norm. So we have to find out the solution to meet these new environment norms. Otherwise, the plant will be have to penalize or shut down. So we have there was the two challenge. First is the existing units, and then Indian coal conditions. This was the first time where Indian coal context this type of solution we was not aware. And second, our aim was that we have to minimize the capex and opex. Then so the technology which we are having, that should have the minimum impact on the, because whatever that we are incurring, that will pass on to the electricity cost. So our aim was to have minimum shutdown and minimum capex and opex. So meeting with this intention and in huge capacity, NTPC capacity around more than 20,000 was impacted with respect to NOx. And as a country, we are leader in NTPC as a leader in power sector. So we wanted to finalize the one technology and how it will impact. So we have gone for combustion modification. So my colleague Iskan Tyagi will deliberate the presentation. Iskan, now hand it over to you.
Thank you, sir. Thank you for a wonderful introduction and precisely, summarizing the gist of the topic that we had selected. So, sir, just to start, for a head start, the NOx control technologies primarily they can be categorized into two heads: the primary methods and the secondary methods. Primary methods they prevent the formation of NOx altogether. So, I mean, whether it is the prompt NOx, it is the fuel NOx, the thermal NOx, they prevent the formation of NOx from the very start. And the secondary methods they try and eliminate the NOx that has been formed. So under the primary methods, you could categorize the combustion optimization, boiler tuning, low NOx burners, and the separate OFA system, which in our case is the combustion modification technique. So when you talk about the combustion optimization, boiler tuning, they pretty much deal with maybe equalizing the PF pipes or running down a simulation software to have a better combustion optimization in the system. When you talk about the low NOx burners, it is categorically achieved in three stages. So in stage one, you would have a combustion would occur in an oxygen deficient, fuel rich environment, and this is typically where the NOx is formed. In the second stage, it will be a reducing atmosphere around the hydrocarbons, and these hydrocarbons will interact with the already formed NOx. In the third stage and the final stage, the additional NOx may be formed from the completion of the internal air staging. However, the additional NOx can be further minimized by conducting the combustion in a lean air environment. When you talk about the secondary methods, sir, the primarily technologies available the world over are the selective non-catalytic reduction and the selective catalytic reduction. So as the name suggests, one is achieved in presence of a catalyst and the other is achieved in the absence of a catalyst. Now, if the NOx that are formed are reacted with ammonia or urea, so to say, then the NOx can be reduced. But to achieve this reaction, it requires the temperature in the range of 800 to 1100 degrees centigrade. So thereby a catalyst is used which accelerates this reaction, and it can be achieved in the temperature range of 300 degrees centigrade, which is just at the eco outlet. So this technology is called the selective catalytic reduction, and wherein you directly inject the ammonia or urea, it is called as the non-catalytic reduction, and a combination of this is called the hybrid SCR. So let us get down to the topic that we are presenting today. As Pankaj sir just summarized the intent of the presentation. So most of the boilers that were installed before 31st December 2016, they had the NOx limit of 750 milligram per nm cube. This is as per the World Bank now. But in December 2015, as he pointed out, the stringent environment norm came up, and the initial ruling was to set the NOx limit to 300 milligrams, but later it was revised to 450 milligram per nm cube. So NTPC envisaged around 50 boilers of 21,000 megawatt for combustion modification, and combustion modification in around 25 boilers is already completed. And implementation in the balance unit will be done during the major overhaul of the unit. So this is not affecting any of the plant cycle. It will not be a disturbance to the grid. It will be done during the major overhaul of the units. And also, just to point out that most of the boilers in India are tangential fired. They're the corner fired boilers. Moving on to the next slide. Yes. So what is combustion modification? NOx reduction is achieved by firing zone and firing by firing the zone under substoichiometric firing condition, by reducing oxygen concentration in the active firing zone, and this is accomplished by introducing a portion of the air higher in the furnace through an overfire air. This is the overfire air damper. The percentage of OFA shall be in the range of around 20 to 25% of total air, and based on the coal quality and NOx turndown requirements. And this OFA management system uses airflow measuring devices, which are provided on both sides of the furnace to control the stoichiometric buildup and combustion processes over the boiler operating envelope. So basically, just to summarize, you are extending the combustion zone. You are stretching the combustion zone so that the NOx formation is limited. And I'll zoom this bar graph as well, just to highlight that whatever type of coal it is, whatever bin combination it is, we were able to achieve the values less than 400 milligram per normal meter cube. So primarily, 3 of the EPC contractors or successful vendors turned out for the combustion modification philosophy. One was, of course, the giant BHEL, L&T, and third one was the GE. So pretty similar designs, pretty similar terminology as well. BHEL, they modified the existing tangential type burner and the windbox system in the boiler, and a newly developed TT burner and a windbox design is introduced. Around 30% of the secondary air, which we just showed you in the previous slide, it is introduced and it distributed in the overfire air damper. It is called the BOFA air. It is termed as SOFA in case of GE, and in case of L&T is termed as the additional air ports. So pretty similar designs and slightly different terminology, and also the proportion of secondary air distribution is different. If you talk about LMB, the LMB utilized the existing system, as much as possible, and they installed the additional airports around the 4 to 5 meter above the existing wind box, which is generally around 40 to 45 meters of the boiler height. And the LMB modified the wind box by modifying all wind box nozzle tips, whether it is the coal, oil, or the auxiliary air dampers, for all the 4 corners using the existing coal burner body and the oil burner. Similarly, for GE, the SOFA, they use the term SOFA. The SOFA tips are designed for plus or minus 30 degree of vertical tilt and manually adjusted horizontal yaw of 15 degrees. Right. So coming down to the limitations. While execution of these combustion modifications in the existing boilers, we did encounter a number of challenges. One was, of course, the furnace size. Now, the furnace is already there, so you need to add the SOFA dampers or with, as L&T calls it, the additional air ports. So the height that you have, 45 meters or 44 to 5 meters above the main wind box, it is pretty limited. So the further size restriction was one of the key criteria which limited how much air you can redistribute to the overfire air dampers. Again, since everything is back calculated, so the mill size restrictions, the pulverized fuel pipe restrictions, the APH sizes, all these became a critical restricting parameters. Another parameter that really affected was the water fluctuation ratio. Now, the heat flux distribution along the different furnace walls, the flow field, the temperature distribution inside the furnace at full and the part loads, they all affect the water circulation ratio and the other flow properties. So this became yet another challenge while executing the combustion modification in our already existing boilers. this was pretty straightforward repetition. And now let us get to the case. So what really happened in one of our units? As always, you to gauge a test, to judge a test, you need a benchmark, a baseline. So first, before modification, a baseline test was carried out, wherein we calculated the UBCs and the spray values for all different mill combinations, and these were summarized in this table. And a similar exercise was done after modifications, so which was termed as the PG test, the performance guarantee test. So here you can clearly see that the unburned carbon loss from the baseline has increased in most of the cases, and also the spray value has increased. So these were the remarkable parameters, and these values, they are a direct hit on the efficiency of the boiler, on the performance of the boiler, which we'll discuss in this slide. So what was the final impact of the combustion modification on the boiler parameters? So when you talk about NOx reduction, of course, as I just showed you, we were able to achieve the NOx values which were guaranteed in our specification. But parallelly, a few other couple of things happened. The unburned carbon loss. The combustion modification amounts to increase the unburned carbon heat loss, including the bottom and fly ash for most of the conditions to the tune of 0.4 to 0.7% at various loads. And UBC heat loss decision percentage shall decrease the boiler efficiency in equal context. So suppose in post combustion modification the UBC loss is increased by 0.7%, then it will also decrease the boiler efficiency by 0.7%. So this was one of the major hits. Now if you talk about the superheater and the reheater spray variation, the SH and the reheater spray variation, they amount to nearly 10 tons per hour and 5 tons per hour respectively. This was kept under limit after the combustion modification. However, the superheater spray was increased up to 21.1 tons per hour, and the reheater spray was not increased. But there was a shortfall of around 20 degrees in the hot reheat temperature. So yet another interesting observation that happened. And in subcritical boilers, generally the superheater spray flow tap-off location is the BFP kicker stage outlet, and the increase in spray value by 10 tons per hour, decreased the turbine heat rate by approximately 2 to 2.5 kilocalories per kilowatt hour. Yet another parameter which will be interesting to note and will be able to eventually gauge in due course of time is the water wall corrosion. The water wall corrosion could not be known initially, but it will only be able to tell you after a long operation of the boiler has happened post combustion modification. But no other significant parameters were other than these happened. But one noticeable change was the HRH temperature, which was lowered by more than 20 degrees centigrade. So thereby again causing a loss in the boiler efficiency. So we did achieve combustion modification. We did achieve the NOx reduction in most of our boilers, but similarly, but parallelly, we had to take a hit on the efficiency and the heat rate, which ultimately reduced the boiler efficiency, and this was a major hit to the generators, since you are not compensated for these values in the pass on tariff that you get. So this was pretty much it, and we'll be happy to answer any questions if you have. Thank you, sir.
Sunavani sir, you're on mute, sir.
Yes. Thank you, Mr. Pankaj and Skand, for giving a wonderful presentation on combustion modification and what is its impact on various parameters of boilers. So in case there are any questions, I think I will keep it open for the other participants to ask questions. Yes, please.
So Navani sir, would you like to ask any questions to any of our authors?
No, I was just wondering whether they have made any petition for the loss they are seeing in the calorific value after this modification? Because naturally they will have to represent to the regulator, and then the tariff will be increased or tariff compensation can be given.
Yes, sir. This is actually in under implementation. So
Right,
what
right,
is
right.
happening?
But
So,
I think it's a really valuable what I can say modification, and the regulators will also agree for it. That is giving some relief to you in the tariff.
Definitely,
Because
sir.
as I see this modification is in a proactive way of carrying the business.
Yes, sir. And impact of this modification is hardly in terms of electricity, hardly 1 or 2 paisa, not
And
much.
that's right. And for that, they will not say, they will not.
Definitely.
Because you will have to implement it at all locations. That is
Yes.
why I read that if
now
you make a representation or you make a petition to the
Mr. Gupta,
CRC, I think they will allow you
Mr.
this
Gupta,
in the tariff.
any improvement in efficiency?
No, that's why we're telling efficiency not improving, but environmentally NOx is reducing. So we are contributing in the environment, and NOx is reduced from 30 to 40% from the earlier.
Right. How
And
you are
we
going to measure this? Are you doing some measurement at the chimney?
Yes, we are doing measurement and giving the continuous measurement to CPCB.
You remember precipitator was when they were put in 1970 or 80 or 85 on the chimney. There was no method of measurement how much is the pollution effect.
That's right.
And at that time, I proposed to them to use the unpiloted, and this piloted now you call drone, which are easily available, and UK was doing it. So there was a lot of conflict in CA itself on the recommendation. I was also part of that committee, and I did said, why not get the from UK help and do this thing? But nobody. Your precipitators were sometimes not working at all, and you are not aware of it. What is happening?
Yes, you are right. You are right. Absolutely correct. But nowadays, we are telling a continuous emission monitoring system.
You have got so many sensors and other things now. Everything is becoming this. I am talking of the past. I'm a past man.
Okay.
Thank you.
Right.
Thanks.
Thank you, sir. Thank you.
Thank you.
I'm 84-year-old now.
That I know. We know. Very active and very dynamic. We have to learn many things from you, sir.
It is again between us.
Yes, sir.
So Navane sir would like to inform that the final presentation, which was regulatory intervention on distribution reforms by Mr. R.N. Sen, sir is actually he's busy in a meeting right now, so he'll not be able to join us for the presentation.
Okay.
So seems like that we are done for all the presentations for today's session, sir.
Very good.
Any final remarks from you or any of our authors would be highly appreciated, sir.
Are there other chairs also would like to contribute, or I should start?
Sir, I can see that Mr. N. Murugesan is here.
Yes, I think we'd like to hear from him something.
Sure, sir. Murugesan sir, are you there with us?
Yes, he's there. Yes,
sir, please unmute yourself. I have sent you a request. So Navane sir, I think we should start with your remarks first. Meanwhile, I'll inform sir.
Okay, madam. The first presentation by Mr. Sunil really gave me an insight. Gave us an insight into what is going to happen in our homes for e-cooking. That is how the load will increase, how people will move towards that e-cooking. The report by the India Residential Survey Council, the report seems to be a very interesting report. I have gone through that report, and I feel that CEW has done a good job to make a presentation on that issue. And what I request is they should continue with this type of studies, so that we get an insight as to what will be the impact on various such issues. The second one was combustion modification, and I really liked it because they have done a lot of work. They have done a groundwork, and they have taken measurements, and they are ready to make their case to the regulator. By this, as Mr. Pankaj just said, the tariff may increase by 1 or 2 paise, but the impact on pollution will be huge, and that I think is a good insight. And I'll also request them to continue on this subject. And NTPC, as it is as leader in the country, so in these various studies also, this was one of the best study I have come across. So I'd like to congratulate both Mr. Sunil, Pankaj, and Mr. Skand for their contribution. And I'm also thankful to India Smart Grid Forum for giving me this opportunity to be with the youngsters, and get information of what is happening. Thank you very much, madam. Thank you, Parul, madam.
Thank you, sir.
Thank you, sir, for motivating us, and we will meet your expectation. And
I'm sure, because the confidence with which your Skand was presenting, I noted that he knows each one figure of it. He has lived the project, in fact. So I was really encouraged by looking at that. And I was also encouraged by looking at Sunil's presentation, because he was also he knew detailed every point on this curve, as if he wanted to tell us something on that point. So that I think I am really happy that the youngsters are doing good job. Thank you, sir. Thank you.
Thanks a lot, sir.
Good evening. Good evening, Sonavane sir. Good evening. This is Surekha Deshmukh from Pune.
Yes, I know. तुमचा आवाज ऐकल्यानंतर मी म्हटलं अरे वा, very good.
Thank you. I thought that I must pitch in and say that okay, this is me, and I got opportunity to share.
Thank you, madam. Thank you very much.
Thank you.
And you have also done a good job. I looked into your paper. It was really wonderful. It's really wonderful.
Thank you.
May I request all the authors and everyone who's present there to kindly turn on their cameras so that we can take a quick group picture.
Sir, namaskar, Murugesan.
Mr. Akash Kumar, please kindly turn on your camera. And Mr. Kumar Skant. Surekha ma'am, please. Yes, thank you. So we can take a quick screenshot.
Right.
Okay. Thank you so much, everyone. Thank you so much to our chairs. And Murugesan sir would like to say a few words before leaving.
Yes, definitely.
Yeah. First of all, it's a great pleasure to be in this particular thing, and it is going on every year. I see that the quality of the presentation is increasing, and I think even the
quality is also increasing.
And that especially we never expect utility to give this kind of very scientific insight.
That is right.
That's a very good part of this conference has produced this kind of thing. And especially in my session, all were very relevant, especially the building blocks of smart grid like substation automation, then advanced metering infrastructure, and then meter related things. So, and even transfer monitoring, these are all very essential for both for reducing the loss as well as increasing the revenue as well as making the equipment available.
Right.
The people have given a practical presentation on that, and we are extremely happy about it. Thank you very much, ISGF and friends who have done it extremely good.
Thank you.
Thank you very much.